Oh, okay. Was it working? All right, let's go back to my dashboard. Oh, streaming. Oh, technology. All right, well, I guess I need to go on my phone. Hey, okay. I think it's working. Am I muted? Can anyone hear me? Yay, I can hear myself. All right, finally. Okay, sorry about the delay there. I was trying to get the dashboard on Twitch to show the video preview, and it did not want to do that for a long time. So, anyways, everything seems to be working now. So I'm going to go ahead and get started. So, excuse me if I sound quite hoarse. I've been sick all weekend, unfortunately, which is like the worst thing ever. So, hopefully, I'm just going to try to power through this. If I start losing my voice, then maybe I will be talking less, but hopefully not. Hopefully my cough drops and Gatorade get me through. Anyways, so kind of to touch on what where we left off last week, I wanted to effectively give a quick rundown about what we did last week, and then parlay that into where we're gonna go to this week. So last week we had mostly it was kind of like project setup, how to opening a Unity project. Kind of talked about some of the methodologies that I go through when I'm starting a new Unity project, like some of the settings that I choose, why I choose them, all that kind of stuff. Excuse me. Also touched on things like naming, how to name files, how I name them, all that fun stuff around there, as well as coding things like using what I'm using. So I'm using Visual Studio, all that kind of fun stuff. So if you missed the first stream, feel free to go to my YouTube channel. You can check it out. There should be a link underneath my on my Twitch channel that'll take you to the YouTube where you can check out the archive of the first episode. But kind of this episode, what I want to do is kind of give a quick recap. So where we left off was effectively trying to define and program what the core mechanic of the game was going to be. So we established some requirements or some limits that we wanted to live by. So obviously it's a mobile title, so we wanted it to be something touch-based, with all phones having touchscreens and stuff. We also wanted to make it something that could be done in a fairly quick amount of time. We didn't want to spend too much time. I wanted it to be something that was within scope of actually streaming once a week and actually getting done in some reasonable amount of time. I didn't want this to take like 5 years to finish. So we kind of came up with this idea, and like I had this idea in my head of something. I just wanted to do something with cubes. I don't know why. There was like cubes were fresh in my brain at that moment, so I wanted to do something with cubes. So anyway, so where we kind of ended up on here was a game where, or a core mechanic where you would see a set. Let's see here if I hit play. Okay. So the kind of the core mechanic that we had was you would have a guide, so effectively a picture of 4 cubes, and say, hey, you want your 4 cubes to match these 4 cubes. And then based on some set of rules, which we haven't fully defined yet, but based on some set of rules, you would click cubes, they would change color, and then as you continue to click, it would also affect the ones that you've already activated, so once you've clicked before. And then the whole point was to kind of think ahead and get the top cubes or your input cubes to match the guide cubes down at the bottom. So that's kind of where we left off the core mechanic. There was a lot of good ideas that came from the chat where there were ideas around, okay, what happens, like how are the other cubes changing colors? Is it the only ones that are touching that cube? Is it only the last cube you cycled? Is it, could you lock one of the cubes and say, oh, this turn, like this one doesn't change colors, or now this one's not changing colors while I change the other colors? There was a lot of good ideas. I kind of wrote all those down, stored those in a file. We'll revisit those later. I kind of wanted to move to a different kind of aspect, because kind of the way that I like to do things is, first thing I like to do is kind of come up with kind of your core mechanic and then prototype it. So that's what I would consider what we see right here on screen. This is definitely a prototype. This is not what's going to go in the game. Now, it tells us a lot about how our design was like, you can learn, okay, is this going to be fun at this point? So for example, I took this, I gave it to my wife, I had her kind of just play through it a little bit, and she was instantly like, oh, okay, I see what's going on, I want to do that. So that kind of shows right there that there is there's some roots to this already. Like there's something there. There's something that we can build off of. And I think that's what's really important about when you're designing kind of a core mechanic, is to find something that even before it's fully fleshed out or anything, that it's something that has some type of, something that grabs you, something that when you play it, you immediately kind of understand what it is, but it's still something that's challenging and makes you want to like solve it. So anyway, so I think we're good kind of on the very basics of the core mechanics. So I would like to move on past kind of the prototyping stage and move on to more of the actual development stage. So last stream, a couple people were asking questions. Oh yeah, and just to kind of preface this a little bit, so if you guys have any questions while I'm going through, feel free to write them in the chat. Last time it worked out pretty well. People just wrote questions in the chat. I was able to get to them, and then I had like a surprising amount of people email me questions as well. So my email is listed on the bottom of the page down here. So it's andrew.ontech@gmail.com. So if you have any questions or comments, you can email me there. I actually got like 38 emails or something like that after last stream, which was kind of ridiculous. So also, if I didn't respond to your email, if you're in the stream and I didn't respond to your email, feel free to email me again. I'm pretty sure I responded to everybody's, but like I was a little unprepared for how many emails I was going to get. So it took, I may have missed yours, and if I did, I'm very sorry, but just email me again and I'll definitely get it this time. And again, sorry for being sick. I'm dying over here, but anyways, so anywho, so kind of had some questions last time about what is my philosophy when it comes to prototyping and actual work, and how do I kind of split the time between how much time I spend prototyping and how much time do I spend actually, putting stuff in that I expect to be in the final product or influence the final product. So something that I like to do is I like to prototype this core mechanic. I like to get something in there and get a real good foundation of what, at least in terms of an idea, that I feel like going with. And then once I got that core foundation of the idea that I kind of want to go with, then I transition that into some of the kind of what I call project architecture. So not just like code architecture, not like the way I'm going to lay out my classes and my objects and stuff like that, but also like how am I going to set up my project? What in Unity, for example, like what scenes am I going to use? How am I going to name my files? What folders am I going to put them in? Stuff like that. So I thought you would never show up again. So yeah, so sorry. I had some weird problems right away where OBS said I was streaming when I first tried to start streaming at 8 o'clock. OBS said I was streaming, and then all of a sudden, like in the Twitch dashboard, it said I wasn't streaming, and then I couldn't get it to refresh, and it kept just spinning, and then eventually I had to kill OBS completely. But yeah, so so somebody in the chat asked some questions last week about multiplayer, and it looks like he tried Photon for Unity, and it worked out pretty well. So that's good. I wasn't sure necessarily on exactly what you were trying to do, so I'm glad you found something that worked out for you. Anyways, so going back to what I was saying, so kind of moving on to the project architecture that I was talking about. So at this point, I kind of want to start kind of designing out, okay, what are some of the things in Unity, like what is my scene structure going to be? So I, based on, my experience working in Unity, I have a kind of I would say a loose idea of how I want to structure the scenes and stuff like that. So if you're not familiar with Unity, Unity has this effectively a scene structure. So the scenes are a list of game objects that are going to be instantiated when that scene is loaded. So so for example, in this scene that I'm currently in, which is main, and you can see up here it says main, and this is your hierarchy. It has a bunch of game objects that have a wide list of components on them, and then all of these are serialized in this scene file. So a scene you can kind of think of as almost like a specification of a hierarchy that you want to be instantiated when that scene is created or loaded, or however you want to say it. So the nice thing that scenes can allow you to do is allow you to easily transition between like a large set of game objects to another large set of game objects. It also does a good job, a fairly good job of cleaning up things. So for example, is all these things are just default. I haven't marked any of those as needing to persist across scenes. When I load a new scene, all of these things get destroyed, all these game objects here. In the hierarchy, they would all get destroyed, and then when the new scene is loaded, all the game objects that are in the new scene would then be created. So I kind of usually use a couple different scenes. Generally, I have a main scene, which I've already created here, but I was kind of using that for prototyping, which is probably a bad idea because I'm going to use main for something else here in a second. But usually the main scene I use for initializations. So let's say I had an app that was connected to like an AWS backend, for example. My main scene or my initialization scene would do things like, okay, the initial handshake with that AWS backend. It would create all my services, create all the managers that are going to live throughout the app, do all those kind of app-wide things, initialize any. Let's say I had a bunch of JSON files that I was using for specifications for game data or something like that. I would load all those at that point. That's effectively any native plugins and stuff like that I would need to import. All that stuff would happen in the main scene. So that way, when I would get into scenes later on, I would already have all that stuff defined. Anyways, so like I said, I was kind of using this main scene as something else for right now. So what I'm going to actually do is I'm actually going to rename this main scene, and I'm going to rename this to game. So this kind of is going to highlight what the structure of kind of my scenes that I want to do. So I have the scene in game, so I want to create a new scene now, and I want to create a new scene named main. And again, this is where I'm going to use, or this is the scene that I'm going to use for all of my initializations, any of my like persistent data loading, any of that kind of stuff. So I'm going to create this main scene, and then I'm also going to create another scene, and then I'm going to save this scene. I'm going to call this scene menu. So, okay. So as you can see, I have effectively 3 scenes now. So I have main, menu, and game. So you can kind of imagine the flow is the app starts, we load into this main scene. Then once everything has been initialized, main scene possibly will also have something along the lines of probably like a progress bar or something like that if we're loading a bunch of stuff. Possibly it may happen so fast that you won't even see what's in the scene. Like it might just be an empty scene. And then after main has officially loaded everything or initialized everything, then we'll probably load into menu. So menu will have things like what type of game type do you want to play? Do you want to change any options? Selecting what level you want to start on, any of those kind of menu-esque things that you would imagine there. And then after you select from your menu, then you would move into the game scene. So the way I want to do this is I want to make it somewhat dynamically generated. So let's say we had 100 puzzles. I mean, that was kind of the rough idea that we talked about in last stream, was that we would have 100 puzzles from start to finish in this kind of the first release of the app. So you could, in theory, have like game_1 or puzzle_1, puzzle_2, puzzle_3, all the way up to 100. That is an option that you could do. The issue with that is it becomes really, really hard to maintain 100 scene files. mainly due to the fact that unless you're using prefabs, which can still not necessarily solve this problem exactly, you might run into a situation where you want to change something. Well, now you're going to have to open 100 scene files and change it in 100 places, which in my opinion doesn't sound fun. So instead, I'm just going to have one game file or one game scene, and in that scene, I'm going to dynamically generate what it's going to be. So eventually, when we get to this point, stuff that you select in the menu scene will then help populate the game scene with things that you selected. So like, let's say you selected level 42, okay? And then we have data saved somewhere that specifies what level 42 would be like, okay? So at that point, when the game scene is loaded, it would reach out, grab the specification for level 42 or the config for level 42, and then it would instantiate the things that it needs, set everything up to make it look like it needs to for level 42. So that way we can only have one game scene, and then we'll just have a bunch of data that is saved outside of the scene that we then load in, and then that sets up our specification, if that makes sense. So anyway, so let's see here. So I have a question in chat. So like I said, I'm gonna periodically be checking the chat kind of in between topics and stuff. So feel free to write anything if you guys have any comments or questions. So I have a question in the chat. How can I make my game not frame dependent? Multiplying by time.delta times not working. Game interactions are totally different on low frame rates. So are you asking how can you lock the frame rate? Such as how can you tell Unity to always run at 30 frames per second? I think that's what you're asking. If that's what you're asking, you can use application.targetFramerate. So let me just open this up real quick. So I'll just kind of show you an example of what I'm talking about. So application.targetFramerate. So let's say you wanted to run your app at 30 frames per second. So you can, that might be an int. Oh, that's an int. That makes more sense. So if you want to run your game at a specific frames per second, you can use this application.targetFramerate. All you need to do is specify this when your app launches, and that should persist its way throughout your app as long as you're not setting it again manually somewhere else. You can also do things like turn VSync on. So turning VSync on can be done inside Unity editor edit, project settings, quality, and then in here you have the option for VSync count. So you can either not sync it, so that's an unlocked frame rate. You can have every VBlank. Or every second VBlank. So effectively, every VBlank, I believe, is whatever your monitor's refresh rate is or your device's refresh rate. And then every second VBlank would be half of that. So I have 165 hertz monitor. So I don't know, whatever half of that would be. So every VBlank would be 165 frames per second. Then every second VBlank would be half of that, whatever that may be. So that's another way you can do that. If you're talking about how do you lock everything in Unity, like Unity's update to always be updating on a fixed time step versus dynamic time step. So effectively making your update code in Unity not be frame dependent. So there's a couple different things you can do there. So number one, you could implement your own tick. So effectively keep your own time scale and say, okay, only update every tick that I specify is, you could say every 1 second. So you could say in a Unity update loop, keep a timer, and every 1 second notify anything that subscribes to this timer that you should update right now. So that's another way you could do it. The easiest way kind of built into Unity is Unity already has a fixed time step here. So if you, inside of Unity, instead of using update, you can use, let's see here, private to void. Fixed update. So fixed update is going to be called every fixed time step that you have set here in Unity. Okay, so that's an easy way to make your code always update. So the really what that's mainly designed for is for when you're doing physics type stuff. Just because you don't want your You don't want your physics calculations to be done on a variable frame rate. Ideally, you want them to be done on a fixed frame rate. So that's why you can use this fixed update here. Another thing that you can do, so this might be probably the dirtiest way, but Unity has, I think Unity has this built in. I think that's a mono behavior thing, yeah. So Unity has this invoke repeating where you can specify a method name and then how long until you want it to start. So you could say like 0, and then how often you want it to update, if that makes sense. So those are all things that you can do. Let's see here. So there's several different options that you can do on that. So when you're controlling, I'm getting a response. So not really. Normally, when you're controlling a character, for example, you do translate some direction speed time dot delta time. So the difference on frame rates would not affect the distance traveled. Correct. Yeah. So that's when you're working inside an update loop. So since every frame, the time between the last update loop and this update loop, this from the last time this update loop was called to the current time that this update loop is called, since that can be completely dynamic, that's why you use the time.delta time to normalize your speed. If you don't want to use time.delta time to normalize your speed, you can use fixed update because you know that your code is being called every X amount of time, whatever you have set in the Unity editor fixed time step. So hopefully that answers your question. Like I said, if you have more, if that didn't answer your question, you want a more in-depth answer, you can always email me at andrew.on.tech@gmail.com, and we can talk about it and definitely go more in depth and hopefully answer your question. Usually that's the easiest for more complicated questions. Anyways, so kind of going back to what I was talking about with the scene architecture. So I have this main scene, a menu scene, and the game scene. So what I want to do in the main scene is effectively what I want to do is create an initialization, so an app initialization method or class or whatever, however I want to define it at this point. But effectively in this scene right now, I don't want there to be anything. This scene is going to load. It's going to yeah. So I would recommend email me. We can try to resolve that. Anyways, so going into the kind of initialization scene. So since all I'm doing right here is initializing stuff, all I really want is possibly, I guess I could keep the camera. Okay, so what I'm going to do is, I'm going to create some UI. I'm going to have a progress bar that's going to show loading. This is kind of a good example. A lot of people I've had over my career, I've had a lot of people that aren't familiar with Unity ask the question of how do I make a progress bar, an asynchronous progress bar in Unity. So this might be a good time to do that. Even though we're not really loading much as of right now, it should be a very quick load. We can do something along the lines of just kind of fudge it, make it take 3 seconds just so we can see a bar progress across the screen. I think that'll be a good example. I've had that question asked to me a lot in my like Unity teaching times. So, anyways, so let's go ahead and let's see here. So let's go ahead and create some UI. So we're going to create just an image for now. So this image, so effectively what I want to do right now is I want to create a progress bar. So I'm going to kind of, right here. So what are we doing? What am I doing? So, what am I doing? All right, so I'm going to, so this kind of note taking over here, this is something that I do while programming or while creating games and stuff. I tend to have a really hard time of kind of remembering what I'm doing, especially when I'm talking to people and stuff. I kind of go off on tangents and whatnot, so I find it good to kind of keep track of what I'm doing. So I'm creating a progress bar to be filled while app is initializing. Ooh, and it's going to be filled asynchro. Oh man, Initializing. There we go. I think that's spelled right. I don't know. If it's not, whatever. It's live. Initializing. I think that, oh man, my head not working too hot right now. Anyways, so first thing we got to do is obviously create the progress bar itself. So let's take our camera, let's switch it to solid color. Let's see here, what color were we using in the game scene? I think we were just using white, right? Yeah, all right. So let's go back to our main scene. Let's grab our camera. Let's make this nice and white, yay. I'm gonna rename this to match our naming scheme that we discussed last stream. So the naming scheme being type and then name, so camera.main. Or camera underscore main. All right, so this is our canvas. So we're going to say it's our root canvas. We'll probably be doing everything under this canvas in this scene, so we'll just keep that there. This is our UI event system. And actually, I'm going to create an empty child. Or I didn't need to make that an empty child, but nonetheless, I'm going to put our canvas and our event system in there, and we're going to call this UI root. Cool. So yeah, so that looks nice and organized for the most part. And then we have an image. So we're gonna call this image our let's see here. Let's call this our progress bar. Actually, you know what I'm going to do? I'm going to create a container for our progress bar. So the reason I'm going to create a container versus just using the canvas as our container is mainly just due to the fact that once the progress bar is created, that'll allow me to easily drag it and scale it around the screen, which as we go through might make things a little bit easier. But again, this is all just completely temp UI, kind of the way that I prototype when it comes to UI and UI related things is I just use like boxes for almost everything right away unless it's something very specific that I need to get more of a visual on. But what I like to do is I just like use boxes, get something in, get the functionality in, feel what the flow feels like, and then in another pass later on come back and kind of start replacing that with real UI. So, but anyway, so this would be what are we calling this? This is our progress bar. Okay, and then we're gonna throw this image in here. So let's kind of see where our progress bar is. Okay, so we want our progress bar to probably be something along the lines of this. We'll just throw it in the middle of the screen for now. We want our image to fill our progress bar. Let's make our image background. I don't know what color. Let's just pick something random. Okay, let's go with like blue. That blue and white looks kind of cool together. I'm cool with that. So, so yeah, let's make this our fill. Image underscore fill. And then let's make another image. And let's call this image underscore background. Let's spell it out background. And then let's make this gray. And then let's make our fill a child of that. And then our fill can be, let's see here, what's our border? Let's see what 20 looks like. Maybe a little too much. Let's try 10. This is going to be 0. All right, that looks a little bit better. So effectively what we're going to do here is we're going to switch this to, the unfortunate thing is in order to make a filled texture in Unity, you have to use one of their, you have to use an image. It doesn't have to be one of their images, but you have to use an image. You can't just use like kind of the blank square that they give you for free, which is something I always find kind of silly. I wish they would just allow you to do that for free. But anyways, so yeah, so let's just make both of these of type UI sprite, or the source image UI sprite. Give it a nice little round bezel on there, I guess. So yeah, so then we can switch this to filled. Oh man, that's gonna look terrible, isn't it? Gross. We don't want to do clockwise. We want to do horizontal. Man, that looks terrible though. So yeah, so at this point I have two options. I want this to not look as terrible. So my options at this point are to either create another image, use it as a mask, and then fill this like so. That's one option that I can do. The other option that I can do is create some art on my own and then use that instead. Something that would look better in this box. I believe what I'm going to do though is I'm just going to create another image. So let's create another fill. Let's use this as our mask. Whoa! Caps lock is on. So mask. All right, and then we are going to add a mask. And then we don't want to show the graphic, and then we want this to be sliced. Actually, let's show the graphic for right now, just so I know where it's at. Okay, and then now we can make our fill huge. So let's go like -20, -20, -20, -20, -20. Didn't need that on the Z. Okay, that's still not big enough. We want this to be quite large. So yeah, something like that. And then now our mask, if we put that as a child, yay! So now it looks better. So now as I fill this, yay! So kind of, yeah, quick recap of what I did there was I created a mask. So you can see, let's make the mask like a weird color, like red. Okay, so you can see our mask. So you can see what our mask looks like. So our mask effectively looks like we want our image to look. So since Unity requires our fill, okay, which is here, let me turn the mask off. Since Unity requires, oh, well, that's not going to work for me, is it? No. So since Unity requires our fill to be effectively a simple texture in order for it to be filled, we get this really kind of grainy, crappy looking texture. So what I did was I effectively made the center of this texture match the mask that I want, or completely fill the mask. And then that way, when it's being filled, it matches our thing, which looks obviously much better. So the only thing that we have a problem with now, as you can see, once I start, it takes me to get to about 24% or whatever in order to start filling it. So we can work on that. So first we can center this in here, and then we can start going over until it starts looking crappy. So you can see it kind of starts looking crappy here. So we'll just go about right there, and then we can do the same thing on the other side. Really, you should be getting custom art made for this, which I will do at a later date. But as of right now, I think this looks decent, and it should serve our purpose. I mean, effectively, what do we get? About 10% before it starts showing. That's fine. So we can progress forward with that progress bar, and then let's also throw some let's throw something else on here. Like let's throw some text. Let's say that we want to some text to say that we're loading. We want people to know that the app is loading at this point. So let's create some text. Let's just say application loading 1, 2, 3, and then let's go. Let's go to this text. Let's center this. Let's center this on here. Let's see here. What looks better? Below or above? I think below looks a little bit better. So let's just make it match the size. And let's throw the text up a little bit. Boom. There we go. Application loading. Yay. So, anyways, the next part would be, I guess, to kind of handle our actual application loading. So what I'm going to do is I'm going to create a new game object here that I'm going to throw some code on in a second. So let's call this code. Let's just go main. So usually what I do is all of the scenes themselves have a code file that kind of manage that scene. So the main scene I'm going to create a code file here that's just going to be called main, and that's going to effectively be like the scene controller for that scene, or like the scene manager for that scene, or whatever you want to say. So let's go C#. We're going to call this main. And usually that just handles things like anything specific to that scene, like setting that scene up, doing stuff that is specific to that scene. So in this case, our main is just going to not really do anything because I don't really have anything that needs to be done at this point. But I just want to go ahead and create it just so that way I can kind of start building this this code architecture, like kind of my class architecture and how I want to do things. So we'll create this main, throw it on here. We're also going to create a folder in here so we can start organizing. We can call these scene controllers or something along those lines. Scene controllers. Throw that in there. And then also we need to create something that is effectively going to live all the time. So I'm going to call this something to do with application. So maybe we can call this, because Unity, so normally if I wasn't creating this in Unity, I might just call this application. But Unity already has a class called application, and I don't want to get to, even though I could namespace it and make it work, there could definitely run into, you could run into some ambiguous reference stuff. So it's better to kind of make your thing be a little bit different. So, so I'm going to call this application. We call this like application controller, I guess. We started going down this controller. What are we calling? Are we calling other things managers? I guess. I don't know. Naming. I'm pretty sure naming script files is the hardest thing in programming, in my opinion. So let's just call this application manager. What is this? What we call that cube manager? Ah, we did call it manager. Cool. So let's continue the manager train. Manager. Boom. All right. So then we can say we have application manager. So application manager, we want to effectively be created when the main scene is loaded. So somebody likes controllers. Well, I guess I made you sad. I went to manager. Sorry. Anyways, so let's go with code, and let's call this application manager. So effectively what we want to have happen is when our main scene is loaded, so that's going to be when the our main scene is going to be loaded right when the app is loaded. It's the first scene that is loaded. At that point, application manager, as well as everything else in here, is going to be created. And then we're going to use application manager. We're going to have an initialize method in there, and that's going to effectively initialize our application and then let everything else know, hey, the app has been initialized, and then it's going to load into the menu scene. At least that's kind of how I'm thinking about things at this point. So, anyways, so we have our code application manager. We want to throw our application manager on there. And let's go ahead and open this. Again, sorry for the coughing and the raspy voice and the lower energy than normal. I am running on straight Dayquil right now. I think that's the only thing that's keeping me going. Hopefully it's not taking away from the awesomeness that this stream could be. But anyways, so we have our application manager. So we need to kind of start thinking about what do we want to do in here. So first thing we want to do is we want to make sure that we initialize, ooh, that's a capital N, initialize the application. So we want to initialize the application. What else do we want to do? Okay, we probably want to, let's see here. We probably want to initialize the application. We probably want to make sure it's not destroyed. So keep this alive at all times. So we want to make sure that application manager is alive at all times. We want to make sure that there is it gets created when the app is started, and then it persists across all the different scene transitions. So the nice thing is we'll never load back into our main scene. We know that because that's our initialization scene. So we can create it in the main scene. We can just tell Unity to never destroy it, and then we should be good. If we were worried that we might load back into the main scene, we could do a check to say, hey, if application manager already exists, don't create it again or something along those lines. But as of right now, since I don't have any design to go back into the main scene again after the initial app launch, I don't think it'll be an issue. So we're just gonna keep that alive at all times after it's created. So, and then the other one would be allow for other classes to talk to this, to reference this. So those are kind of the three things that I want to do right now. So let's go ahead and start kind of doing this. So, so the easiest way to allow for another class to reference this would be to just make this, make a static instance of this that can be, or a static reference to this that can be handled, or that can be accessed from other classes. So I think we were already doing that somewhere. So yeah, so we're already doing that here in Input Cube Manager, if you remember from last stream. So for me, it's just easy to just copy and paste this. That way I don't have to go through and just type all this stuff again. So we want to create a public static of this time of type application manager. We're going to call it sinstance, and then we're going to have an awake method. So when it's created, so when the main scene is loaded, it gets set. So cool, no problem there. And then after we create that, that should then allow any other class to then say, hey, can we grab this? So something else that I kind of want to talk about, or that I wanted to do, is when we were initializing the application, I wanted to have a way for people to say, hey, has this been initialized or not? So I'm going to go ahead and create another, let's see here, pound region. What do we want to do? We want to make this a property, or do we just want to make this? Yeah, you know what? I'm going to go ahead and make this. We can make this a property. Yeah, because we don't want anybody else to be able to set this. So we're going to go ahead and make this a member property. And so what we're going to do is we're going to create a private variable. We're going to create a private bool. Oh, not a bool. Private bool. And we're going to call this is initialized. Man, I keep getting those capital N's. And then we're going to set that to false. And then we're going to create a public bool that allows our other classes to then check on this. But we can say public is initialized. And then, like I said, so we don't want anybody else to tell Application Manager that itself is initialized, or that the application is initialized. That's all going to be handled handled here. So instead, so we're not going to allow anybody that has a reference to this to do anything other than just get what it's currently set to. So we're just going to rename, let's see, we're going to return is initialized, and then we're not going to specify a setter. So that way, anybody that has a reference, or anybody has this S instance, which anybody can get to because it's just public static, they can't actually set what is initialized is set to. All they can do is just get what it currently is. So this will be nice, so that way at any time during the app, for any reason, so if we have some more complicated calls that need to happen during the main scene, we can check, oh, has the app been initialized? Oh, okay, now I can go ahead and run my code that I need to. So anyways, so let's see here. What else do we want to do? So, okay, we need to actually initialize the application. So let's go ahead and create region helper methods and region, and then we're going to create a private void initialize. Well, that was initialized, not initialized. Initial. Oh man, autocomplete. You're killing me right now. It's so good sometimes, and then sometimes it's the worst. Initialize application. Cool. And then in initialize application, at the end of it, so when we are finished initializing, let's flag our app as initialized. Cool. And then at that point, we can set is initialized to true. Ah, that's not true. True. Boom. Cool. So, so even though we're not actually initializing the application yet, there's nothing happening in here. Effectively, what this is doing is when initialize application is called, when it finishes initializing, it will then flag is initialized as true, and if anything else is paying attention to that and worrying about it, they will then get it and know that it's good to go. So, so we're also going to then, okay, how do we initialize the application? So at this point, we just want to initialize it as soon as the app has started, or at least that's what I want to do, is begin initializing as soon as the app has started. So what I'm going to do is I'm going to create another thing here. So, so I'm going to create private void start, and then again, awake is always called first. Start is called second. So you can guarantee that all the awakes are called before any of the starts are called. So let's see here. So start we want to call initialize application. Excuse me. Initialize application. And then at that point, as soon as the app is started, it should call initialize application. We get in here. We then do any of our initialization that we want. And then afterwards, we'll then mark our app as initialized. So somebody in the chat asked me, how did I learn all of this? So it was kind of a combination of things. So I went to college, standard 4-year college. I actually studied game design and 3D animation in college. So I didn't actually specifically study programming in college, but I did some kind of like student projects, and then on the student projects, so this was like early in my college, so like freshman, sophomore year, I was doing student projects, and while doing those student projects, we didn't have anybody to program for us. So I was kind of the youngest on the student project, so they were like, you have to do it. So effectively, I started teaching myself how to program, and I actually kind of liked it. So what I did at that point was I started taking some computer science classes. I ended up finishing with a computer science minor, but effectively taught all, stuff you learn in college, especially only getting a computer science minor. You're not really learning how to program video games. Like, you're learning more like kind of core concepts about programming and stuff. It's not really completely, or I don't know, it's not really applicable to my real world day-to-day, at least. 99% of what I do on a day-to-day basis was just self-taught. Hours and hours and hours. I built 2 mobile games completely from scratch while I was in college, and I would say each one probably took me at least like 200 hours to do. I worked my tail off making those. And through that process, I found tutorials online. I used resources people that I could find online that knew Unity. I reached out to them. They helped me. I just kind of kept going and going, and eventually I got a job. And what was funny was my job was actually doing Nintendo DS, 3DS games in C++. I actually wasn't even doing Unity. While at that company, I suggested effectively for a project that was coming up that we use Unity. They liked my suggestion. They did it. I worked on that project, and then I've been kind of using Unity in my career ever since. But yeah, so like pretty much everything that I've learned has been self-taught through online resources, through Unity resources, trial and error. A bunch of it's just trial and error. A bunch of it's like, hey, I want to do this thing. I want to make a progress bar. I'm just going to sit here and keep doing stuff until I can make it. And that's kind of how I got to where I am today. But now that I work, 60 hours a week doing this, it's a lot nicer to be paid to teach yourself something, if that makes sense, versus like doing it in school. So effectively, I taught myself as much as I could on my own. That allowed me to get a job, and then through the job, I've learned. Since I became a professional engineer, I've learned 100 times more than I did as like a student. So it's really, really once you get into it, it makes it a lot easier to learn more about it. So I always thought of naming. So yeah, so somebody's commenting about saying the difference between start and awake and the naming scheme and stuff right there. I agree. It's not perfect. There could be better names for some of the Unity lifecycle events. The way I look at it is awake is effectively as soon as the code is created. So as soon as it's almost like a constructor. So it's as soon as the code is created, awake is called. And then you can be like awake in your bed, but your day hasn't started yet, if that makes sense. So like that's kind of how I look at it is awake means your eyes are open, but you haven't necessarily started moving yet. Start is like, okay, I'm awake and now I'm actually doing something. But yeah, so those are kind of how I try to keep track of them. At this point, obviously it's like imprinted on my brain from using it so much, but that might, I don't know, be a way that's easier to help it. So. Oh yeah, so somebody's like, but I wake up first before I start doing stuff. So that's funny. Like, I didn't even read that comment. That's totally the example that I used. Awesome. I'm glad we're thinking alike here. So Excuse me. And again, sorry for being sick. It's like makes this not as great as it could be. So, anyways, okay, so we need to initialize the application. Okay, we took care of that. Okay, so here's another big thing. We want to keep this alive at all times. So there's a couple different ways to do this. We could not even use a mono behavior. Instead, just create like a system object, and then when the app is started, we create a new version of that, and then that object just lives in memory across scenes and stuff. But in kind of the vein of keeping things more Unity-esque, if that makes sense, we're going to go ahead and just use something that's built into Unity. So we're going to say keep alive through scene transitions. And then we're going to call DoNotDestroyOnLoad. And then we're going to say this. Bam. We can call it GameObject. Doesn't really matter. What's important about this is GameObject makes sure that any of the components that are also on this GameObject will maintain across scene loads. So anyway, so for people that haven't used DoNotDestroyOnLoad before, effectively what this does is when Unity goes to clean up all the objects, this object will be flagged as, hey, don't destroy me. So when you're transitioning scenes, it'll persist. So I should be able to actually test this really quickly. Let's go ahead and say initialize our application. So let's go to our main scene, our main code. Let's see here. So let's go main. And then again, this is a scene controller, a scene manager that I was saying before. So what do we want to do in the scene manager? So we want to go, let's create #region Unity methods. So all we want to have happen here is we want this code, which is going to load up as soon as Unity is open. We want to wait until the scene has been initialized. Once the scene has been the application has been initialized. Once the application has been initialized, we want to then load the menu scene. So let's go ahead and let's do private void start. And then what's really cool, oh god, again, autocomplete killing me. What's really cool about the Unity lifecycle stuff though, so like start, is I can actually make this a coroutine. So I don't know if any of you guys are familiar with coroutines or not, but coroutines are effectively a way for Unity, a way in Unity to call things kind of asynchronously. I don't know, it's kind of hard to explain. I'll see if I can kind of explain something. So imagine that you have your update loop is being called like this. So update. Let's see here. Update. Okay. So let's imagine your update loop is being called like this, and this is happening. Let's say that the timing between this is, I don't know, 10 milliseconds. Sure, whatever. Again, I'm just throwing out numbers here. This is not like anything specific. So let's say this is how your update loop works. Okay, so every 10 milliseconds your update is being called. Okay, so the cool thing about a coroutine is it allows you to call something outside of that structure, if that makes sense. So let's say I started a coroutine and we called this coroutine, let's say we're using our start here. Start's a bad example. Let's just call it my coroutine. So my coroutine. Okay, so let's say my coroutine is called here. Okay, now what's really cool about this is we can tell our coroutine to halt execution at any point in the coroutine, which is really cool. So we can say at this point, we can say we want our coroutine, we want the first third of the code in our coroutine to be called here. Okay, then we can tell our coroutine, okay, we want our coroutine to wait 5 milliseconds and then call the next half. Okay, so what's cool about that is effectively imagine this. Okay, so that's a bad example. Let's say we wanted to do every 20 milliseconds, okay? So what's going to happen is the first third of that's going to be called as soon as you start it, like you said, and then you can tell it to wait for 20 milliseconds. So effectively what's happening is your coroutine is going to keep waiting until 10 milliseconds, 20 milliseconds, and then the next time it can be called, let's just cut my coroutine. And then at this point, the second, or the end half, well, whatever, let's just call these halves. This might be a little bit easier to explain. Okay, so the first half is called here, and then your second half is called here. So that's if you told your coroutine to wait 20 seconds or whatever, or 20 milliseconds or whatever it is. But effectively, it just allows you to wait on time, wait on variables, do things like that. It's not running on a separate thread, and that's kind of the biggest misconception that people have about coroutines. So if you're coming from a more standard programming background, you should be familiar with multi-threading. So running two things in parallel or running things on a background thread asynchronously from the main thread. Okay, so that's not what coroutines are. Coroutines are still running on the Unity main thread. All they're doing is you're determining manually when the execution is going to happen, if that makes sense. So let's go ahead and make start here. Oops, I'm typing the wrong thing. Let's go ahead and make start here a coroutine, and hopefully this makes this a little bit more clear on what I'm talking about. So, okay, so we have this. So anything you want to make coroutine, you can just make the method an IEnumerable. And then at that point, you can do things like, okay, so we get into our start method. We want to, effectively, we want to wait until, what do we want to wait to? We want to wait until our app is initialized. Our app is initialized. Okay, so we want to wait. So there's a couple different ways you can do this. So so all coroutines are based around this kind of this yield concept. So that effectively you're just saying, hey, yield or wait execution of this method until something. So you can do yield return new wait for end of frame. Okay, so effectively that's going to say, okay, wait until this current frame is ended and then execute some code. That's something you could do in there. The really common one that is used a lot is wait for seconds. So you can say like, okay, I want you to start running this code. So we can actually throw some debug logs in here to help it make it a little more clear that this like code is running. So so debug log, and then we can say started our coroutine. And then yeah, we could wait for a half a second, and then it would then execute the code after that, for example. But the one that excuse me, wait for so yeah, so you can do a couple other things like wait until, excuse me, where you can pass in like a bool predicate. Excuse me. Oh man, I'm burping like crazy. And then you can do wait until. I think what is the other one? Wait for. Is it wait for? Wait while. There's a lot of different stuff you can do. If you ever just want to wait for one frame, you can yield return null, and that'll effectively just wait one frame at that point. So that's kind of what I'm going to use here. And while you could use one of the other returns to make this a little bit like more like one-lined or whatever, I like doing it this way, and this might just be because I'm a little bit like stubborn in this, but this is just the way that I've always done it, so I'm going to continue to do it this way. So we're going to go, so while, let's see here, application, and a good thing here, again, I want to mention, so here that we're in a start, okay, not in a wake, we can then guarantee that our S instance of application manager has been set because of the fact that that's set in an awake. All the wakes are called before starts, so we know that that's going to be set. So we can freely grab, let's see again, application manager .s instance. So we can grab this S instance, and we don't have to be worried that it might be null. Now, if we were worried that it could be null, like in a case where we're using like a static instance of something else, we could always just check like to make sure it's null before we do some type of check, like we could do, let's see here, application manager .is initialized. S instance .is initialized. So this would be completely valid here. What's cool about like doing it this way, and if you're a more novice in programming, you might not know this, but if this check is false, okay, you're immediately going to be kicked out of this this conditional. So this would never actually be called, or would never try to be looked up. So because of that, you don't have to worry about your S instance being null in this case because you're checking for it first. But we know that our S instance is not going to be null, so I'm just going to go ahead and do it like this. So effectively what I want to do is, while our app is not initialized, I want to sit here and I want to wait. That's what I want to do. So I want to sit here and wait until our app is initialized. Then once our app is initialized, then I want to go ahead and load our menu scene. So we're going to, oh, and this is, I know Unity has updated this recently, so there's like, not editor, but is it scene management or something like that? So it used to be application.loadLevel, but I know they've changed that recently. So let's go ahead and see what. So let's go Unity load scene. And this is a common thing that I'm doing quite often, or that I do quite often, is I need to look up syntax. Like, I knew there was a new scene manager, load scene, blah blah blah, but I just couldn't remember exactly what the syntax for this was. So okay, so it looks like scene manager dot load scene, and then you just pass in the name. Okay, so let's go ahead and copy this. Let's go in here, scene manager. So our scene name, if you remember, is just the name of the scene file. So in our case, we want to load menu. So we're gonna go back here. I'm gonna go menu, and then I think, well, we're missing a reference. What are we missing? Okay, so using Unity scene management. Okay, menu, and then I think we have to pass something else in, right? Is there, unless you do not have to. Okay, cool. So we don't have to. We can just pass in scene name. Cool. So we're not going to try to do any type of like fancy scene loading or anything like that here, like an additive scene or an asynchronous scene load or anything like that. Our menu scene should be pretty light, even in the final rendition of this. So we're just going to keep it simple here. Anyways, so okay, so we want to load our menu scene. So something that's really important if you're ever loading scenes in Unity that a lot of people forget and then get hung up on is you need to make sure that you remember to actually add them. Let's see here, file, build settings, to your build settings. So right now you can see I have 0 scenes in build. So I want to go ahead and just grab all 3 of these and throw these in here. So not only do they have to be in here in order for you to dynamically load them in the game. So like if we want to load from the main scene to the menu scene, it has to be inside this menu. But on top of that, the order that's in here is also going to determine the what scene is loaded first in your game. So you want to make sure whatever scene you want to load first is set as scene 0 or the highest thing in the list. So in our case, we want the main scene to be the thing loaded first once we actually make a build. So we just go ahead and put that up top there. Other than that, since we're just going to be dynamically loading all the rest of the scenes, and we're loading them by name, not by index, it doesn't really matter what order we put the rest of them in. So we're just going to go ahead and keep it that way. Let's go ahead and save our main scene. So yeah, so I think at this point, let's see here. Let's review the code real quick and see, what was that? Application manager. I just closed that. I don't know why I did that. Oh yeah, that's why I did that, because of line endings. Line endings, the bane of my existence. So anyway, so if we look at the two things that we just added, so we have the main scene and then we have application manager. So we probably don't need these comments anymore. Okay, save that. So when the app is started, okay, the awake method here is going to be called, because this exists in the main scene, which is going to tell it, hey, don't destroy me when you load scene, and then it's going to set the instance, so the static instance that we have here, to this, so that way we can reference it from anywhere. And then once all the awakes are called, the start's going to be called, which is then going to call initialize application. So right now, again, we're doing nothing here. But after it's done, quote unquote, doing nothing, then we're going to set is initialized to true. Okay. In our main scene, what we're going to be doing is we're going to start our coroutine, and then we're going to wait until it is initialized. And then once it's initialized, it'll then progress through there and go to menu. So what's really cool here is let's try to like really kind of show what this can do. Oh yeah, so sorry, I dropped my notes over out of there. So let's really let's see here. Let's go back to here. So yeah, so let's kind of show what this can actually do. So let's grab another, or how coroutines work. Let's try to make it more clear. Let's see, debug.log. No, I said log. Thank you. All right, so we started our coroutine, and then let's say we are waiting for is initialize to be true. Okay, missed boom, and then let's throw one more debug log here. And let's say loading our scene. So yeah, so what's cool about this is this when I hit play, I'm gonna have the console up, and then we can actually watch these print out as things are happening, which will be cool. So right now in this current state where application manager just calls initialize application, boom, it goes. It's just going to be instant, like it's going to be super fast. So instead, let's just add a fake delay here. So we're gonna also make this IEnumerable, and then we're gonna add a yield return new wait for seconds, and then let's just hold this up for 3 seconds. Let's put a comment here. Wait for 3 seconds for no reason. Yay. Let's wait for 3 seconds for no reason. Okay, so here's one of the biggest problems Unity has with coroutines, in my opinion. One of the biggest problems, and I'm going to mention this right now. So let's see here. So we have this coroutine initialize application, and then we're calling initialize application from the start method here. Okay. Well, if we go to Unity and let it compile, okay, if you notice, we have no errors. We had a warning about line endings, but we have no errors, and seems like nothing's wrong. But if we ran the code, this initialized application would not be called. And the reason behind that is because we're trying to call it like a normal method, when in actuality, we need to call start coroutine like this in order to actually call this. What are you mad about, bro? Cannot convert from oh, oops. That needs to be IEnumerator, not IEnumerable. My fault, my fault. Would I make this IEnumerator? Oh, yeah, that needs to be IEnumeration. See, everybody makes mistakes. I make mistakes all the time. All right. That's what compiler's there for, help you out. Anyways, so in order to get this initialized application to actually run as a coroutine, we have to use the start coroutine method to actually start it. So that's kind of like a little weird thing in Unity that tends to get people a lot of the times is they'll be like, hey, why is my coroutine not running? It's not running. This doesn't make any sense. I'm calling it. I don't have any errors. When the problem actually is just they're not using start coroutine. So that's a common issue. So I wanted to make sure I highlighted that. Anyways, so okay. So the way the app should work, so let's kind of run through exactly what happened. We should hit play in the main scene. The main scene should call awake, not destroy this, set its instance. Then it should call start, which should start the coroutine initialize application. At this point, the initialize application should wait for 3 seconds. Then after the 3 seconds, isInitialize should be set to true. At which point, our wait here that we're doing should then progress past, and then we should load our menu scene. So what we should see in the console is we should see started our coroutine. That should happen instantly because that code is being called as soon as start is happening. Then we should get waiting for initialize to be true a bunch. Okay, we should see that keep ticking up until, well, for 3 seconds. And then after that, we should see loading our scene. And then also, since we're saying do not destroy and load, when we get to the menu scene, which I think the menu scene is completely empty at this point. Yeah, so when the menu scene is empty, so we should, when we get here, have application controller or application manager also here. So, okay, so let's go back to game. Oh, nope, main. That's where I want to go. And also, let's try to fix this line ending before it bugs me for the rest of my life. Okay, so let's go back to Unity. Okay, so again, when I hit play, we should see in the console. So I'm going to turn collapse on. So if anybody doesn't know what collapse means, that just means if you get the exact same message more than one time, instead of showing it a bunch of times in a vertical list, it'll just give you a little ticker over here. Actually, you know what? I'm trying to think. Yeah, I'll keep collapse on. This is where it gets tricky because the problem with collapse is it doesn't necessarily show you the correct order that it's being logged in, so there can be some issues there. So we'll leave that off. Okay, so as I hit play, we should see started our coroutine. We should see waiting for coroutine for a while for 3 seconds, and then we should see loaded our scene. So let's see if that's what happens. Okay, so we got, if you can see at the top, we got started our coroutine here at the top. Okay, then we got a bunch of initialize, or waiting for initialize to be true. So we got it for 3 seconds. Then we got loading our scene, and at which point we then loaded into the menu scene. You can tell at the top it shows you which scene you're currently in. So it says menu here at the top. And then on top of that as well, we have our code application manager still existing here. Yay. Okay, so now, so that's kind of like the very, very, very foundation. I'm going to remove these logs now because we don't need these. That's kind of like the very, 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 very basic foundation of kind of an initialization scene. At least the one that I want to create for this, where we start initializing, we wait until the initialization is over. Once the initialization is over, we then load into the menu scene. Okay? So at this point then, we want to update this progress bar. Okay, sounds great. So so now things get a little more complicated because we're like, okay, now we have this UI that needs to be updated. So it's like, okay, one option could be we could control that from Application Manager. Application Manager could get a reference to the progress bar. It could fill the progress bar as it's being initialized. Okay, sure, that works. That could work. But at the same time, then you're getting kind of like some interdependencies that aren't great. Because what happens is Application Manager lives in all the scenes. So once that progress bar is destroyed, now you're going to have a null ref sitting around. And let's say somebody tries to seize that they think there's a ref there. Now, granted, I'm the only engineer on here, but there could be more people in the future. You never know. There could be issues. So it's probably better to keep that logic out of that. So then you're thinking about, okay, so if we wrote some UI code, so let's go back to Unity. Let's create a folder. Let's just call this UI from now. And then let's just write some UI code. So I don't know, what are we calling this? Progress bar. Okay, we can probably get a little more specific than that. We can say that this is the main scene. So let's create main UI. So UI main. Okay, so this is going to effectively control all the UI in the main scene. So right now, all we have is this progress bar, but we might have more stuff in the future. So let's just go ahead and do something a little more generic here. So we have this UI main. So in this UI main, what we want to do is we want to update progress bar to reflect application initialization progress. Okay, so effectively what we want to do here is we want to update our progress bar to reflect the application initialization progress. So at this point it's like, okay, well, we can get a reference to Application Manager. That's not hard. We already know that that's possible. That's not an issue. Hold on. I have a feeling it's going to complain about the line endings. Oh, it's not going to complain about the line endings? Make up your mind. Is it going to complain now? No? Okay, whatever. Anyways, so we already know we can get a reference to the Application Manager pretty easily. That's not a problem. We can just grab this S instance. Not an issue. But here's the problem. All we get right now is a bool saying whether we are or are not initialized. We don't get a progress. We don't know what the progress of the initialization is. So instead, what we should probably do is we should probably create some way of getting that information. So we're going to know that information here because it's all going to be happening inside this initialized application. So there's a couple different things we could do here. Is initialized, so we could set something up more complex and we could have a class with a bunch of different stuff like, is it initialized or not? What's the current state of initialization? Is it downloading things? Is it loading things? Is it creating things? And what's our progress? You know, we could get a lot more complex here. But again, I don't see this application growing to needing super, super complex initialization logic. If it does, we can always convert the initialization to be more complex in the future. But for right now, I'm imagining it to be pretty simple. So I'm just going to go ahead and I'm going to create a progress property that we can then just read from. That'll kind of tell us where we are in the initialization progress. So we're going to go private, let's go float, initialization progress. Ooh, and then that's going to be private, so we need an underscore in front. Oops. And we're going to make that 0. And then we're going to go public flute. And then we want this again. And then again, we're just going to provide a getter here, not a setter, because no one else should be setting this progress. This progress should be only set inside of this class. So let's go return. Boom. Nice. Okay. So what this is going to allow us to do here is that inside of our UI, we can then update our progress bar while the application manager is updating. So first thing we're going to do is let's go ahead and go in here and let's create region member variables end region, and then we're going to go public. So I don't know if this is something that I touched on in the last stream or not, but any variable that you make public inside of a mono behavior that lives on a game object will be visible in the Unity inspector and then allow you to then set your reference right there. So I'll show that again here in case I didn't make it clear before. But anyways, so what is our type? What do we care about at this point? So really all we care about is the fill bar on the progress bar. So we're just going to go ahead and we're going to say we want an image. So of type image. So as you can see, image doesn't show up in my autocomplete, and that's because we're not using UniEngine.ui. So now that we're using UniEngine UI, it knows about image. So we're going to do public image, and we're going to call this progress bar fill image, and we're going to set that to null. Okay. So by doing that, what's cool is inside of Unity. So if you haven't worked in Unity, oh, now it complains about me. Oh man, I'm gonna. Is that UI main? Yep. All right. Line endings, man. I don't understand how to fix it. There's got to be a way to fix it. They are really a thorn in my side because I hate warnings. Everybody hates warnings. You don't want to see warnings. Hate warnings. So anyways, sorry, I'm going off on a tangent. So let's go to our canvas root where I put the UI code. And notice now that since I created that public variable, now I have an option to set an image here. So I can go down into my children. I can find my image fill, which I have down here. Again, remember, filling this sets this bar right here. And then we're going to go ahead and we're going to go into progress bar canvas, and then we're just going to drag that in. So that's one way to do it. You can also hit this little, I guess this little dot next to it, and it'll show you everything in your scene. And you can search and you can say like, okay, I want, fill, and it'll filter it out for you. As well as you can look at assets. So we'll touch on that more later if we get to like prefab initialization and stuff like that, or instantiation. Sometimes you want to assign the prefab that you want to use from the scene. Or from the project versus from the scene. But anyways, so we set our fill here. So what's cool about this is now in our code, this variable, we know when this code goes to run. Doesn't matter if it's in an await, doesn't matter if it's in a start, doesn't matter anything because it's done like compile time effectively. We know that this has a reference now. So we know it's going to be filled. We don't have to worry about it being null. So let's go pound region. And then let's just do, probably the easiest thing to do here is just, let's do another Unity method. So really you can make a decision about what type of fidelity you want in your progress bar updating. If you don't care if it's a little bit choppy, you could possibly do a little bit more performant way of doing this. I personally want it to be as smooth as possible, and this scene is going to be pretty simple, so I'm not really worried about performance on this scene. And even if it gets more complex, it shouldn't be a scene where there's any input from the user or anything like that. So really having low performance doesn't matter that much. So I'm going to do private void, and then I'm just going to set this in an update method. Oh my gosh, I really keep forgetting that autocomplete is on, and then I keep doing that. Habits. So what's nice about doing it in an update now, and what's nice about setting this as a public variable that I reference, is I don't need to then worry about getting it. I don't have to create it. I don't have to do anything. It's just already there. And then that's stored So that reference then is then stored in the YAML that's created for each of these scene files. So it's serialized to disk for me. So I don't have to worry about it not being there. So like when I go to a different scene and come back or whatever it may be, that is still set there, and I don't have to worry about that. So that's a very nice and convenient thing that Unity does. So in here we're going to go, let's see here, progress bar, fill image, and then we should have a fill amount. And then remember, we just set up inside of our application manager, we set up this initialization progress. So we can just go ahead and call application manager dot sinstance dot what do we call it? Progress, initialization progress. And since this is just a float between 0 and 1, or at least that's how I plan to use it, and that's how, excuse me, fill amount is set, this will then automatically pop itself over. So there's a couple different things that we might want to do here, but for all intents and purposes, this is the basics here. So I'm going to get rid of some of these extra usings just because they're wasting space. But let's go back to Application Manager and let's actually fill this initialization progress with some information. So we know in here, okay, we are filling every 3 seconds. Okay, so how do we then break it up? So this is just like straight up dummy code. But we can then, instead of doing it like this, we can do something along the lines of, let's create a float. Let's see here, elapsed time equals 0f. Okay. And then we can go while elapsed time is less than or equal to 3f. We yield return null, and then we increment this elapsed time plus equals time dot delta time. Okay, so effectively what I'm doing here, which, I mean, I don't know if you would ever want to use this on like actually doing something, but this is, I mean, at least for debugging, making sure your progress bar is working and stuff like that, this is something that you can do. So, so effectively what I'm doing here is I'm creating this variable elapsed time. So as soon as this code is called, it's going to be initialized to 0. Then it's going to come in this while loop. It's going to check, okay, is elapsed time less than 3? So remember, 3 seconds is how long we want to wait. So yes, of course, it's less than 3. So we yield return null, which remember waits for 1 frame. So that's going to wait for 1 frame, and then we're going to increment our elapsed time for how long that frame took to wait for. So so this is, remember, time.delta time is how long the last frame took. So effectively all we're doing is we're creating our own little timer here. So we're saying, okay, wait here for 3 seconds. But now what's nice about this is we can do then a calculation for our initialization progress to allow it to be a very high fidelity progress bar. So we can go underscore initialization progress equals, and then we can say elapsed time. So how long have we been waiting here, divided by 3f. So that should give us a percentage of how long we've been waiting over the 3 seconds that we declared. So also, again, magic numbers, like just throwing 3 here, even though like it's pretty clear in this case, is not a good thing to do. So instead, I always recommend saying like time to wait equals 3f, and then using this instead, just because that way, if anybody else working in this code or even yourself at a later date comes in, you can see, okay, hey, I know this is time to wait, and I know these variables are the same. So if I want to change time to wait, I just change it here. I don't have to worry about remembering if I change it here, oh, I got to change it here too, or my calculation is going to be off. So anyways, so the last thing I want to do is, just because of like weird like rounding errors and stuff like that when you're dividing floats and whatnot, at the very end when we're done, let's go ahead and also set our progress to 1. That way we know that that our progress bar is always going to be full. We're not going to get in a weird situation with that. And then let's say somebody out there writes some code and they actually are worrying more about initialization progress versus is initialized. It'll make sure that they get an accurate reading at the end of when it's finished. So so anyways, so now what our code should do is our fill then should fill over 3 seconds, and then we should load into our menu scene. So hopefully that's clear to everybody. Let's see if it works. Maybe it doesn't. Maybe it does. Who knows? Let's find out. Yay! It looks like it worked. So yeah. So that's kind of like a very, very simplistic way of looking at making a loading bar. So now you could do a lot of different stuff here. So you could use this loading bar, the same concepts of a loading bar, several places in your app. Let's say you're loading an asset bundle off disk, which is like a Unity's way of compressing assets and storing them to disk, or at least one way that they can do it. So let's say you're loading a file off disk, okay? And you're loading it asynchronously, and you want to have a progress bar showing that you're loading the file. You could use this code. You could use you could use this for downloading a file. You could use this for loading in between scenes. Like, let's say you needed to load tons of assets into your game scene. You could use this for waiting in a multiplayer situation, like sending. Let's say you had a messenger app and you wanted to send a picture to somebody. You could use this type of loading bar for that. Literally, it works for anything because it's all just based on this initial this initialization progress or any type of progress. So as long as you have a way to update your progress, which we do here in this initialize application, then you can use this same concept across any type of thing that you could use a progress bar or loading bar for. So anyways, so back to where we were. Effectively, I think we are at this stage of the app. So without knowing more about this application, about things that we need to do, which would come more from like a design, like when you start designing more things, like how the app's going to work and stuff. There's really not much else we can do in the initialization scene. That's weird. Did my text just disappear? That was weird. Anybody else see that? My text just disappeared. Weird. Unity bugs. Gotta love them. Anyways, so one of the things that are really cool is that while making a game, you should really be paying attention to concepts like this. Like, okay, here's a loading bar concept. Now that you've made a loading bar once in your life, throw that in your pocket. And now you know how to make a loading bar anytime you need to make a loading bar again. And that's kind of like where I'm at this stage in my life, is that I've made a lot of games, a lot of different games. I think I've shipped like 13 different games at this point. So like being able to take these concepts that I do on a daily basis, every time I do something new, just put it in your pocket. And then next time you need to make a loading bar, you have it. So as time progresses and as you gain more experience, you're going to have tons of these little like snippets of concepts. Like, here's how you make a loading bar. Here's how you load a file asynchronously. Here's how you create a UI menu. Here's how you design something, blah, blah, blah. And then those things you just keep in your pocket and then like next time you need one, boom, you just pull it out. So that's kind of the, that's how I've learned. Is I didn't really say like, oh, I'm learning game development, I'm going to go learn everything else, or like everything there is to learn about it. Instead, what I did was I kept learning kind of small concepts, and then as I would learn a small concept, I would just store it and then build and build and build. And now I have like tons of these small concepts and that I just, use on a daily basis. So anyways, so, okay, where do we go from here? Now that we have a loading bar, and let's show again this loading bar works. So now let's go and let's start building kind of our menu. So our main menu. So let's go ahead and go to the menu scene. So what's really nice about Unity is Unity itself is very friendly for prototyping and building stuff really quickly. So for me, like a lot of people in traditional game development might go to possibly like a flowchart app or some of the other type of prototyping apps that there are out there, and they would go to these things and they would use those to build mock-ups of their UI, of what they want their UI to look like and stuff, and like what's the flow going to be when you click this button, where does it go and stuff like that. But for me personally, it's so easy to create that stuff in Unity that you might as well just create it there, because that way if you find something you like, you already have kind of a basis for your UI. You don't need to create it in one application and then come over and then like build it again in another application. Like, to me personally, that doesn't make any sense. Why build it in two places when you can just build it in one? So So anyways, ooh, excuse me. So let's go ahead and let's start thinking about what we want the main menu to look like. Okay. So again, this is where I'm kind of just using a very white theme, clean colors throughout the app. So if we go back to like the main scene, remember we're just using white with gray and then like a blue progress bar. So like really clean, like not really worrying about it too much at this point. It's super easy to come back and skin this stuff a different color or a different shape or any of those things later. So there shouldn't really be a worry about that kind of stuff at this stage. It's my philosophy that while you're kind of still prototyping, I would consider this kind of borderline prototyping and actually building something at this stage, but you really shouldn't worry so much about the way things look unless your app really is dependent on looks. So for me, like, it's not that big a deal. So anyways, so we got a main menu. So something I never touched on the very first time we started talking, but I've already kind of decided that we would go like a portrait mode versus a landscape mode. So just so you guys clear what I'm talking about, this is landscape, this is portrait. So we kind of want. My whole idea around this was it should be an app that you can use one hand. You know what I mean? You don't need to hold it with both hands. There's no reason. You don't need to hold it and tap with the other. You should be able to just kind of hold it with one hand and use your thumb, or at least in theory. So what's important about that is that kind of user experience you need to make sure is consistent across the entire app. So if we go back to the game, it's simple. Like there's cubes that you're clicking. So there's no reason you can't click those cubes with just your thumb. So now if we go back to our menu and we start thinking about how we want our menu to be, we should kind of remember at least that we want to maintain that same usability across all the things. So let's just kind of take some notes about what we're doing. So let's see, creating main. Oh, excuse me. Creating main menu, and then inside of creating main menu, some of our concepts, I guess, would be one hand friendly. Oh my gosh, typing is hard. So we want to make sure it's one hand friendly. Matches rest of app and provides easy access to functionality for app. So again, provides easy access functionality app. That should be a given. I mean, you shouldn't have a main menu that's hard to navigate. Like you don't need 30 sub menus no matter how complicated your game is. It's just, it never makes sense, especially for a mobile game. Like if you got to give people access to stuff that they want like immediately. In my opinion, it's usually one page. So your main menu, think of it in a series of pages. So your main menu might have things like play a game, options, and quit. Okay, for example, maybe that's what we'll throw up here in a second. If those are your options, each of those go to another page, and that's as far as they should go. So when you hit play game, you shouldn't go play game and then hit another page where you have some more options like, oh, play game type A, play game type B, then go to another page, select this level, then another page where you select difficult. No. That's terrible for a user. All those screen switching, that takes time. People get disinterested. It's not great. So instead, like let's say you had two different types of games. Let's say you had a type A and a type B. Well, instead of having play game, then select between type A and type B. Instead, just have play game A, play game B from that main menu. See how that cuts down on a page? And now instead, you can then go to the last page they need to go to right away from one click instead of having 2 clicks to get there. So that's kind of the goal for this app. Is I want it to be simplistic. It's a puzzle game. It should only take 5 minutes to get into a game, play through an entire puzzle, and then get out. There shouldn't be an issue with, oh, I got to navigate through 30 submenus to get started. So as of right now, I think there's only going to be one game type, at least, in my brain, there's only one game type. So I'm going to focus on only having, like one game type. So I'm not going to worry about sub menus of multiple game types and stuff like that. So let's go ahead and let's see if we can remember what our color was that we use for our progress bar. We can use that for colors of our buttons, or at least one of our buttons. So let's go back to main. Let's look at our progress bar. I like that color too. So what is this? Blue. So I'm just going to go ahead and take. So Unity doesn't have a great way to like copy colors, but one of the things they do have is they have this presets down here at the bottom, which is kind of nice. So you can add a preset for this color. So I just went ahead and added in a preset. So what's cool about that is oh yeah, I never know that you could switch between that. Cool. What's cool about that is you can create different libraries and stuff like that. But what I usually use it for is I just set a preset like this, and then now I can go back to my menu scene, and let's say I want to make this button background that color. So I can go there, and then boom, that preset's right there, and now my button's that color, which is, in my opinion, something that's awesome. I like that a lot. So that's a good feature of Unity. So. Anyways, so to kind of continue our theme of what I was talking about before, which is one of having a very one-hand friendly menu. So let's make it one-hand friendly. So let's go with huge buttons. Let's go big buttons here. Big buttons. Everybody likes big buttons. And let's have a couple buttons. So let's go with this one's going to be play game. Let's add another button. I'm going to call this. Well, I'm going to rename these as I go to help keep things organized. So it's going to be play game. Create another button here. Call this options. And then let's create another button here. And let's call this quit. So we got 3 buttons. So something I want to do here is just to kind of make layouts and stuff like that easier. So if you remember how I created, let's actually take a step back here and let's go back to the main scene. So if you remember, I created for the progress bar, I created this root. Okay. So the reason I created this root was I wanted, and this actually needs to be set to like, okay. So I wanted to create something so that way, if I wanted to move the progress bar around, I could move the entire progress bar. I didn't need to move each individual piece in here, the mask, the fill, the background. Instead of having to move all those, by putting them under one root, that allows me to just move the entire thing. It allows me to scale the entire root, and then everything underneath scales correctly, which is great. So I kind of wanted to make sure I maintain that throughout the entire app, just because that's going to make development of this much, much easier. So let's go ahead and let's use one of Unity's built-in layout groups. So we're going to create a game object here, and let's place this game object, sure, right there, it doesn't matter. And then let's make all of these buttons children of this game object. And this game object, we're going to add a layout component, and we're going to use a vertical layout group. So what's cool about this is a vertical layout group is effectively going to take everything that's a child of it, and it's going to lay it out based on some specifications that you specify over here. So first of all, we're going to make the group a little bit bigger so that way it actually fits in our UI. Okay, so I'm going to make it here. So we get a couple different options here. So if you can see, it might not be easy to see on this right editor window here, but so notice the buttons are linked to the upper left hand corner of the layout. So by switching this, for example, to middle center, now you can see that they're in the middle layout, which is what I want for this. So by playing around with these things in here, you can also change things like how much spacing is between them. You can do things like padding, like you can add extra padding on each side. There's a lot of different options you can do in here, but using these layout groups in Unity is an easy way to utilize their UI system in a way that makes it easier to develop. So let's see here. So somebody asked about if I can upload these to YouTube. So I'm already uploading these to YouTube, so there shouldn't be an issue there. If you see my YouTube channel, at the name of my YouTube channel is in the bar at the bottom of the stream, as well as the link to my YouTube channel is in the underneath the Twitch channel. But I can also in the chat, I'll post a link to, actually I think I already posted a link to my Twitch channel possibly, but I'll go ahead, or my YouTube channel, but I will I'll go ahead and post that again here in a second. 1 second. Let me grab the link to my YouTube. Yeah, you should be able to just search Andrew on Tech, maybe. Yeah, on YouTube, and I'll come up. It's using the same picture as my Twitch channel, but nonetheless, let's go ahead and post that in the chat. Cool. So if anybody is looking for my YouTube channel, I posted it in the chat. So hopefully all the archives, not hopefully, for sure, all the archives from this will be posted on my YouTube channel. And also, if you guys have feedback, anybody that's watched the YouTube videos or is watching this on YouTube, give me some feedback. Right now, I'm just literally taking the stream and just throwing it up there after I'm done. If you guys feel there might be some benefit of cutting it up in a certain way, so that way there's smaller files a piece, like multiple videos, like an hour each, because I know sitting through a 3-hour-long video might be hard. I was thinking definitely what I might do is timestamps in the video. So that way in the description of the YouTube video, you can kind of jump ahead in the video to different things like, oh, okay, I'm creating the main menu here. Okay, I'm talking about coroutines here, so on and so forth. Hopefully something like that. I'm not sure. I'm really looking for feedback, though, because I've never really done this live stream and then post to YouTube kind of thing. I've only done, like, edited videos on YouTube. So let me know either in the chat or send me a comment on the YouTube video, or send me an email with any suggestions you guys have around that. So somebody asked, do I have any ideas about what this game will be about? So yeah. So if you've missed the first stream, please go to YouTube and watch it. It's on the YouTube link of the channel that I just linked in the description, in the chat. So in the first stream, we took a pretty deep dive into what the game is going to be about and kind of how to come up with an initial concept for a game. But to kind of give you a quick overview again, so it's a mobile game that's going to be on iOS and Android. It's a puzzle style game that is meant to be something you come in, you play a level. The level takes about 5 minutes or so, and then boom, like you're done with that level, and you can either play another one or you can be done. So it's really like grab, play, come back, grab, play, come back. It's not like an RPG or something where you're going to sit and play for hours. That's not what the goal is for this. So the core mechanic, which we kind of talked about in the first, well, not kind of, we talked about a lot in the first stream, which again is on the YouTube channel. The core mechanic around this is around 4 cubes, and I guess I can show this while I'm talking about this. So I don't know that's not what I want. There we go. So let me go to let's go to game. So yeah, so the core mechanic around this is you have and this is still a little bit up for debate about things like how many cubes, how many colors, what are the order of them, and stuff like that. But the kind of core mechanic is you see a set amount of cubes in a certain color configuration. And your whole goal is you need to match your cubes to match that. And as you click on cubes, they cycle between colors, okay? But as you click other cubes, once they've been activated, so taken out of this gray state, the rest of the cubes start changing colors. Now, the design around how they change and stuff like that hasn't been designed or anything. We talked about possibly it's only adjacent cubes, possibly it's the cube you've clicked on last, possibly it's some other rule set. Maybe the rules change each level. That hasn't really been designed yet. But the core concept is you have cubes, and you need to effectively make the cubes that you have match the guide cubes. And then each level would be different cubes down at the bottom, as well as possibly more colors. Maybe instead of 3, like at the beginner levels, there's just 1. Maybe there's less amount of cubes. Things like that. And you want obviously the difficulty to ramp up as you go. So that's kind of the core concept. But we talked about it much more in depth in the first stream, so please go to YouTube and check that out, because these are definitely meant to be watched kind of in series. So hopefully that answers your question. So let's get back. So now that we're back at the main menu, let's go back to our layout group, and remember I'm going to rename this too, so we're going to call this layout group, and this is going to be, I guess it's just main menu. So anyway, so in this layout group, we have, like I was talking about, we have a bunch of options. So we can change things like how the children are aligned. We can also do things like say, okay, we want the height and width of the children to be determined by the size of the layout group. So for example, let's just do just width right here. So if I change like the height of the child, for example, you can see it allows me to change the child. They can be different sizes and stuff like that. But then if I go and change the entire layout group, notice the width gets updated to what the entire layout group is. So if I select, okay, height as well, now it's the same thing. So both of those are being now determined by the layout group. So that's kind of what I want, just because I want all the buttons to be the same size and have the same spacing. So then I can go like 20 in spacing. And so you can see as I change the size of the layout group, it'll automatically change the button size to match, which is really nice like later on, because there's definitely situations where you're like, oh, now I need a fourth element in here. Okay, but I want it to take up the same amount of space. So now, boom, I add that fourth element, and guess what? Now I got 4 buttons. And like, you can go on and on and on. And what's really nice about this is, like, if you ever do things in the game where you have something like a list of options, and your options need to be dynamic based on, so like, let's say save games. Here's a good example, save game files. Well, we allow you to create 5 save game files, okay, in like an RPG or something. So in that case, you would need anywhere between 1 and 5 options to show. Okay, well, 3 options, you know, look good, and then but you also want 4 options to look good and 5 options to look good. So using a layout group like this that auto resizes the children that are in it, or the UI elements that are in it, can really help you achieve some stuff for, like, again, for really cheap. Like, you saw how easy it was for me to just throw a layout group on there, click some settings, boom, it's there. So anyways, let's go ahead and let's set the text on these. What is this? Options. Ooh, not my options. I mean, that might be an interface at some point, but not the name of that button. So quit. Cool. Let's also go ahead and let's make the font a little bit bigger on these, just so they're easier to see. Let's go 50. Cool. So here's actually a really good point of something that I haven't been talking about with the UI that I probably should be talking about. So one of the good advantages of Unity that Unity does for you is all of its UI has this thing called a canvas scaler. So as everybody should know, every mobile device, or a lot of mobile devices, have different sizes. Okay, so one mobile device might be 1280 by 720, another one might be 1920 by 1080, and so on and so forth. So how do you counteract that? Well, Unity has this nice thing built in called a canvas scaler that allows you to do a thing called scale with screen size. So what's cool about this is it allows you to set like a reference resolution. So we're going to do 1920 by 1080. And yes, all of our stuff is going to get tiny, and I'm going to have to switch it in a second. But what's really cool about this is that as the resolution changes, you can see the UI stays the same size on the screen. Like the same percentage of the screen is taken up no matter what what your resolution is set to. So what's really nice about that is it allows you to build one UI, deploy it to multiple device resolutions, and boom, it just looks good on all of them, or at least looks pretty good. I mean, you might get into weird situations where going from things like an iPad, which is like a 4:3 aspect ratio, to like a 16:9. But nonetheless, like this can definitely at least get you started. So, so now here's a good example of what I was talking about with the layout groups. So notice our UI is tiny now. Okay, but now that I put everything in a layout group, I can very easily, boom, make this layout group bigger, and now, bam, our UI is great, like size-wise. So there's a couple things I want to do here. Is now that we're working on a higher reference resolution, I need to up things that are using pixel values, such as our spacing. Also, our font needs to get a little bit bigger, which is fine. Let's maybe jump that up to 100. Let's go maybe 125. Okay, so that looks better. And then, yeah, so let's go ahead, and before I forget, let's also go back to our main scene, and let's do the same thing here, and let's set our canvas scaler to 1920 by 1080. So again, our stuff's tiny, but since it's in just a grouping, I can make it much larger. And then let's grab our font. Let's make this a little bit bigger. What were we using before? 125? That's probably good. Yeah, that looks good. Cool. And let's save that. And then, yeah, again, so this is all going to scale then as I change resolutions and look good. So that's a really nice advantage of using a canvas scaler. I highly recommend it. It does add a little bit of performance just because I believe Unity, I don't think they're caching it off exactly the way they should be. I don't know. You can, if you use the Unity profiler and check out stuff, like there's definitely some hit, I believe, from using a canvas scaler, but it's not something that you're going to necessarily notice unless you're like really on the bare edge of performance. But okay, so let's go back to menu. So now we got our play game, our options, and our quit. So like I was saying before, each of these things we just want to move into, like, either these things go where they need to go, or there's like one page and then you're there. Like, you don't want to, like, that's kind of the one page rule is what I like. You never need to go farther than one page to get to where you're going. So play game, for example, you hit play game, it's going to give you an option of the different levels that you can choose. So I'm thinking of something along the lines of like a scroll list that has all 100 options on it, and you have to like beat level 1 to get to level 2. So like right away, level 1 is unlocked, level 2 is locked, and so on all the way up to level 100. Then once you beat level 1 once, no matter the amount of stars, 1 through 3, then you unlock level 2, and then so on and so forth. And you just keep doing that to get up to level 100. Again, we're trying to keep this simple. So so what I'm thinking is just a scroll list that has all 100 levels on it, and then and it's just like a bunch of like squares. So like maybe there's like 4 squares or something, and then 25 rows of those or whatever. Something pretty simple. Options should be like, I don't know, sound. So like mute if we ever get some like sound effects. So maybe sound effects volume and background volume. So we can show implementing a slider. So that's probably good for tutorial purposes anyways. I don't know what other things might be in options other than sound options. Possibly we could get crazy and do something along the lines, allow the user to select like a color scheme. That'd be kind of cool. That was something I've always thought about doing that not very many people do. Is like effectively allowing people to choose like the tint of all their own buttons, kind of give them a little more of a unique experience. I thought that would be kind of cool. I don't know, other things like that and options. If I supported multiple languages, which I don't plan on doing, I just want to point that out. Just because localization is a cluster of a lot of work. So we're going to support English, and that's what we're supporting. But maybe if you had multiple languages, that would be a location where you would have some options for changing languages and stuff inside of options. And then quit, obviously, you hit quit, the app closes. Pretty simple. I like having a quit button. Not every app has a quit button. Obviously, you can just quit it from your operating system, Android or iOS or whatever it may be. But I don't know. I like having a quit button. Also, what's really cool is that what's cool about having a quit button is it allows you to log events on quit versus having just the app like effectively like force quit. So there's cool things around that and stuff. So yeah. Hi, Pikaru Bonsai. I think that's your name. Sorry, my secondary screen that I use for the stream is actually tiny, but just want to say hi. Anybody that says hi in the chat, you'll get a hi from me, that's for sure. But anyways. So let's go ahead and let's start kind of thinking about what we want the architecture around the UI to be, because we're going to be switching between these pages and we're going to need UI for those, and some of them might be dynamically generated, some of them might not be. What are we going to do? So, so kind of what I'm going to do is I'm going to start thinking about that stuff. So what I like to do usually is each screen or page, as we want to call it, correct. So somebody mentioned in the chat real quick. So they were saying you have on application quit is something you can use, which is true. On application quit in theory is supposed to be called whenever the application is quitting. Fair enough. Except in cases where the app actually ends up crashing because of the quit. So what can happen sometimes is effectively when something is happening, okay, so let's say you're referencing some variables or you're doing something with, especially if you're doing anything where you're talking between Unity and the native layer, so like Objective-C or Java or anything like that. So things that can happen is you can have like a pointer to some native code. And when the OS tells your application to quit, effectively it says you're quitting now. You don't have an option. You're quitting now. So the issue that can come at that point is if Unity gets a null reference exception at that point or any other type of exception, your on application quit won't actually fire. At least that's something that we've ran into in my day job quite a bit. So on application quit in theory should be able to be called whenever your application is quitting, but what I've noticed is when you're force quitting from the OS level, sometimes you'll get an exception that'll effectively stop your thread from executing and your on application quit from calling. So that's something to be aware of. So we're running into an issue in my day job currently where whenever the app crashes, we send out a crash log that then gets uploaded to like our servers and then sent to us so we can like see, hey, the app keeps crashing at this point or whatever. But the problem that we keep having is when the app is force quit from the OS level, we keep getting a bunch of crashes. So what ends up happening is not only is our on application quit not working, but we're getting all these crash logs just from people like normally quitting the app from the OS. So that's something I wish Unity handled a little bit better. But fair enough. But you can use on application quit, which is a callback that Unity has, or an event that Unity has. You can use that if you want. Just be noted that sometimes it doesn't always work. So, anyways, going back to what I was talking about before. So, when I'm talking about like these pages, so like the options page or the game select page, or screens or however you want to talk about them, usually what I like to do is I like to have a separate piece of code for each of them, if that makes sense. And then that code handles everything on that screen, if that kind of makes some sense in there. So what I'm going to do is I'm going to kind of go ahead and I'm going to start creating that code for that and creating the objects for that and stuff. And then what happens then at a level above that is you have something that manages or controls turning that code on and off. Okay, so we'll have what we're looking at right now is the main menu. So you'll have a main menu code which handles the main menu. Then you'll have a select game. Then you'll have an options or play game. I don't know, whatever we want to call it, options. And then quit doesn't really need anything because you're not going to a different screen. So we'll have four. What was that? 1, 2, 3, or 3. We'll have 3 pieces of code. Then we'll have something above that. We'll call that like our UI controller or something along those, or UI manager, or UI screen manager. I don't know, something along those lines. And what that'll do is that will manage things like turning it on and off. So effectively, we'll maintain some type of state on there. So that way, at any time, we can say, "Hey, UI manager, what screen are we on?" Okay, and then kind of cycle between those. So that's kind of what I'm expecting to do. So, okay. So somebody's asking a question real quick. So totally new to game dev. Does Unity generate an APK or, sorry for the off-topic question. So Unity. So let's take a dive real quick into Unity's build settings. So Unity actually has a couple different options that it can do for you. So if you just select the default build settings, yes, it will just straight up generate an APK for you. At that point, you need to make sure that you have your build settings set up. So such as like getting your key store set up. Obviously for debugging, it's not as important, but when you're actually publishing to the store, you got to make sure you set all that stuff up. Same things that you would set up if you were using like an Android Studio project or Eclipse, which I don't have much experience with. I just know they exist. And then Unity just goes ahead and signs and generates the APK for you. But if you don't want to do that, Unity does have an option. Now, granted, I'm going to be straight up. I've never used it, but they do have an option to actually export the project to, I believe, to an Android Studio project, I believe. Or maybe it's an Eclipse project. I don't know. You'd have to check Unity's documentation on that to know for sure. But by default, yes, Unity generates an APK, and then, but they do have an option to export a project. I just can't remember if it's in Eclipse or if it's in Android Studio, or do you have the option to switch between them? That's possibly what Gradle and ADT, maybe ADT is Eclipse, Gradle is the new Android Studio project. I'm not 100% sure on that, but by default it does generate an APK for you. And then for people who are curious about iOS on the other hand, always generates an Xcode project for you. That's just because iOS does not allow you to do things like code signing and deployment and stuff, publishing, stuff like that through anything other than Xcode. So when you build an iOS project in Unity, it will just generate an Xcode project for you. You open up that Xcode project, and then you build the Xcode project in Xcode, and that actually generates like your IPA or builds it to a device or whatever you need to do. So hopefully that answers your question. Yeah, so I'll be switching the project over. Actually, I can go ahead and probably switch that over to Android now if I wanted to. Oh yeah, thanks, because that's what I wanted. So I got rid of my aspect ratio because apparently they're project specific. Thank you. Okay, there we go. So yeah, so we're actually running on Android now. There's a couple different things that Unity does for you when you switch projects like that. Things like image compression that you have set up specific for platform. Also, if you're using encode, reload all. So let's say in code you were doing something along the lines of pound if Unity Android. So you can see as like while I'm on Unity Android, this pound define is true. But if I switch to EVGA precision, get out of here. I don't know why that on-screen display decides, hey, I'm gonna be turned on for no reason. So anyway, so if I switch the project though to let's see here, let's go back to PC Mac. In theory, yep. So you can see it actually comments out this code now. So Unity does that stuff on the fly, which is pretty cool. So yeah, those are some of the things that Unity does with when you actually select a platform in Unity. So we're eventually going to Android, so we can go ahead and switch that. That's just something that isn't super important right away. So I didn't really think about doing that from the get-go. So, anyways, okay. So we need to go through and we need to start creating kind of the structure for the pages for our different screens. So we're going to go ahead and we're going to, excuse me, we're going to create, let's see here, let's create a C# and let's call this, so now is when we get into the question of how we want to kind of architect things. So I'm going to make a decision at this point, which might come back to bite me in the butt, but I'm going to make a decision at this point. I'm going to say that our main menu is excuse me, is that we're going to have one UI controller that effectively lives across the entire app. So or our UI manager. I guess we're on the manager train. So let's continue on the manager train. So UI manager. So surprisingly, it's something that manages the UI. Okay, so we got our UI manager. Let's throw that in our UI folder. And then let's also go back to our main scene. So granted, at this point, there's nothing in the scene that needs to use the UI manager, but it's probably something that will need to happen at some point. So we're just going to go ahead and we're going to add this here. So we're going to create an empty child. We're going to call this code. So again, like here's some of the things that I'm doing that you don't have to do. Some people, like you could just have one game object in here and put all three of these pieces of code on them versus having one on each. The only reason I like doing it this way is it allows me to really easily look in the inspector, or sorry, in the hierarchy and see what code is in the scene at this current point. So I can see, okay, I have a UI manager. Why is my code not working? You know what I mean? Stuff like that. It's just a kind of a debugging tool. But that can get real dirty. If you have like 50 things, then your hierarchy can get really, really, really dirty. So at that point, you might want to consider possibly, consolidating that in some way, shape, or form. So anyways, let's go to save. Okay, so we got our UI manager. So our UI manager doesn't really have anything in it at this point, but eventually it will. So let's actually open it up because there's one thing we definitely need to do. So if you remember from our application manager, one of the things we need to do is we need to make sure we keep this alive through our scene transitions. So we're going to go ahead and we're just going to copy and paste this code into our UI manager. Since it's the same thing, we want to make sure that it exists throughout all of our code. So wait, what's going on here? Why? Oh, I know why. Because I started a region and didn't end it. Cool. So again, so this just makes sure that it stays alive across all of our scenes, which is something important since this code is going to be used by a lot of our different scenes, or well, technically all of our scenes. So again, the stupid line endings, which are the bane of my existence. Anyways, so then let's go back and let's kind of start thinking about how this is going to work then. So our UI manager is going to be effectively in charge of our screen or our page transitions. So it's going to be in charge of what screens are showing at what time, and effectively what screen is currently showing in case anybody needs to know, or what screen just showed and stuff like that. So let's go back to our menu. And let's kind of start thinking about the different screens that are going to be there. So we have our main menu scene, our main menu page or screen. So let's actually go ahead and let's create a folder in here. Let's call this screens, and then let's throw this UI main in there, since that's our screen from our main scene, if you remember. So let's create some more here. So we're going to have C#, we're going to go UI, and then we're going to have main menu. And then we're going to have UI, let's see here, well, we can call it play game, select a game, I don't know. It's more like, I guess technically you're selecting a game, but you're hitting play game to get there, so we're just going to call it play game. Let's call it select a game. I like being very descriptive in my code names. Just makes it easier in the long run, especially when you're trying to debug and figure out what the heck things are doing. Then let's see here, UI options. Cool. So these are kind of our new screens that we're going to have. So so we kind of already have this layout group here in this main menu. So our main menu currently, we're probably going to have more than just this in our main menu screen, possibly like a username. If you have a username, like let's say we have an account system or something like that, or maybe we want to show like your current progress or something like that. So I'm not gonna say that this is the only thing in there. So I'm going to actually create, let's see here. So I'm going to create another, actually, I don't want that to go out there. I'm going to create another object, a UI object. So create an empty child, and then I'm going to put this in there. But I'm going to first make this fill the entire screen. And then this is just going to be kind of like the container for our main menu. So we're going to just do that, and we're just going to call this UI main menu. And then that's where our UI main menu code is going to go. So see how like I think this is important. It makes it easier too, is like doing things like naming your game objects in the hierarchy something that matches your code. Like you want to make sure it's something that is that there's some type of connection between there. That just makes things like resolving conflicts and issues and stuff like that much easier. So all right, anywho, let's go to let's create some more of these. So we need to create, let's see, create a child, set this to stretch. Also, I guess I haven't really been talking about how the layout stuff in Unity works in terms of the rect transform. And also, if there's anything I'm doing on screen that you guys are like a little bit lost on, just mention it in the chat and I can touch on it a little bit more. But anyways, so there's a couple different options you can do where you're selecting like pivot or anchors. So what I'm doing here is I'm just selecting stretch. So what stretch allows me to do is effectively specify a border. So you can see like through these blue handles. So this is the object that I'm currently have selected and where it's going to be. So so all I'm doing is I'm setting the border to be 0, and what this does is just fills the entire screen. So no matter what the resolution or aspect ratio is, this UI object would fill the entire screen. So that's convenient for the kind of the root UI screen. So that way, like, you're working inside the space, so all the children inside of it work inside the space of the entire screen. At least that's what we want for this. Now, we might have more screens in the future that would not be the case, but for these screens, that is the case, since they're full screen screens. So let's see here. What else do we have? We have menu. We have select game. We have options. Boom. Cool. And then let's go ahead and throw code on all these. Oops, UI screens. So we have select game, options, Cool. So, alrighty. So let's make sure. Yeah, Unity has this weird problem where when you duplicate objects, it likes to mess with the scale a little bit and make it like 0.99, which doesn't seem that big a deal. But the problem is once you, like, if you have that a bunch of times and you keep having children of children of children, the effect gets worse and worse. And all of a sudden you have stuff that's like effectively rendering at like 0.7 or something like that, which is not great, to say the least. But I'll be, so I'm going to have to take a break real quick. I'll be right back in like 30 seconds. I need to go grab another Gatorade. My throat is way too dry for not drinking water. Alrighty. Sorry about that. Like I said, I've been like super sick, so my voice is usually not even close to this raspy. But anyways, back to what we're doing. So we went ahead and we created these. So now we know that our excuse me, our kind of our what's the correct term here? We know that our screens or whatever need to be activated and deactivated from something. So we were going to do that through our, let's go back over here to our, where are we at? Main. Okay, so we're going to do that through our UI manager, okay? So now the question comes, okay, how are we going to know based on like what state or something like that, what UI needs to show and so on and so forth. So there's a couple different options you can do here. We could have for each scene, we could have a scene specific UI manager, and then that scene just handles, okay, in this scene, I know if I'm in this state, this UI shows. Okay, that's something we could do. You could also do something along the lines of like a string lookup. So let's assume that we're not doing any prefab instantiation here. Let's assume that in our menu all of our code exists, but it's just like turned off. So effectively when like we would have these two objects turned off, and then in our main menu, when we would select something, main menu would go toggled off, and then this new object would be toggled on, which would have more UI in it and stuff. So that's something, I mean, we could do. And let's go ahead and let's actually create some stuff real quick here. So this is just for debugging purposes. I'm just going to create some text to throw in each of these screens. The nice thing about this is it's just going to let us know, hey, we're in the screen. So I'm going to be like select game. Oh gosh, select game. So let's make this text much bigger. Okay, so we know we're in select game, and then this in here. Call this one. So this is gonna just allow us to know like which menus, sub pages, or which screens are open at a time. So yeah, so there's a couple different things you could do. So number one, you could do have all of these in your scene, and then just toggle them on and off based on which screen you're currently looking at. Okay, that's one option. Another option that you could do is you could actually create prefabs out of these, which are just specifications of a hierarchy of game objects and components, and then instantiate those. So create those at runtime based on which screen you currently want to show. So there's definitely pros and cons of each. For a super simple UI like we're gonna have, I definitely like the approach of having everything in your scene and just turning it on and off. And the main reason for that is because it's super fast. So effectively the memory for these things has already been created. So when the scene is created, it creates the memory for this stuff. So when switching between these, you're actually just kind of like pulling something out of a cache versus instantiating something, like creating something in memory from nothing. So by doing it this way, you get really, really, really crisp and fast scene transitions. So when you click on something, it's like immediate. The downside of this is obviously you have more stuff loaded in memory at a time. And if you're memory bound, which we definitely will not be, no way in shape or form, you could run into an issue there. So if we ever had an issue where we had all of our menus together were going to be too big, then we could run into an issue where we might not want to do it this way. But again, like I said, I'm a firm believer of pick the best structure, the best tool for the project you're in. So don't overcomplicate something. I mean, there's a like my favorite thing ever is like KISS, KISS, which is keep it simple, stupid, because people tend to over-architect things all the time and overcomplicate things, and it just bites you in the ass in the long run. So honestly, pick the best tool for your job, and I think for our menu structure, this is going to be the best tool. So now, okay, so the question becomes, when UI, so when our UI controller gets in here, how does it know to turn this on, turn this off, and stuff like that? So that's where things get a little bit more complicated, because since it doesn't exist in this scene, it doesn't actually have a direct reference. So that's why, now that I'm thinking about it, I think I'm actually going to change the architecture a little bit. Instead of having one, let's go to main, one UI manager that lives in all of them, I think each scene is going to have its own. So so again, and this is very, very, very typical of this stage of game development for anybody out there that's kind of new to this, is you may think you have a great idea right away, or you may kind of have a vision of how things are going to go, but as you think about things and as you start doing stuff, you can definitely, change that. I mean, I would say most projects, out of the final code base that gets put into, production, like there's 75% more code that was just deleted. Like you write 10,000 lines and you delete 7,500 of them and ship 2,500. Like that's the way it works. Like it's all about doing something, seeing if it works, how well does it work, and then coming back and refactor. Refactoring is like such an important thing in my opinion. So anyways, so let's go back to our menu scene now that we know we kind of want to do it a little bit differently here. So so what I'm going to do is I'm actually going to have like a UI manager for each of the scenes, if that makes sense. So let's call this UI manager, and we're doing this like menu. And we're going to put this right here on this canvas. Yeah, I know. So Unity's mad because Unity wants your classes to be named the same as the file name. So that's why it was not allowing me to add that there. So if I put this, wait, no, UI manager. Nope. Man, too much cough medicine apparently. Let's see here. UI manager menu. That looks a little bit better. So let's go back in here. UI manager menu, and then let's throw that on canvas. Come on, what are you mad about? Come on. It says the script class cannot be found. I know, it should have the same name. Did I name it wrong? I might have named it wrong. Let's copy that. Let's go back here. No, did I not save it? I don't think I saved it. Yep, I didn't save it. That was my fault. All right, anyways, so let's throw that boom on here, and again we're just going to put this in the root, so it's going to be in our root canvas. But let's actually, now better yet, let's remove this. Let's create an object. Let's see here, create empty, and then let's have a root UI, and then we'll throw the code on that. So it's UI root. I think that's what we did. Again, I'm trying to keep the same structure between scenes. So I want to see what I did here. Yep, UI root. Cool. That's what I did. So so yeah, I want to make sure I keep the same structure between scenes. It's just going to make working in between scenes like so much easier when it all follows kind of that same structure. So here's our UI event system. And then UI root. Okay, so on here is where I want to put our UI manager. Cool. So now, I mean, the question comes like, is there really that big a difference between like our scene manager and our UI manager? Maybe. Could those be consolidated into one? Possibly. That's kind of the decision you need to make at this point, is like, how tied to your app do you want your UI to be? But I'm cool with this. So I'm actually gonna make the scene manager manage the UI as well. So let's just call this menu. Again, I know I've changed this file like 5 times. So let's change it back to menu. Let's go back here. But this, I mean, this is a normal process, kind of thinking about things as you go and making sure that you have a good idea. Because sometimes, you know, you might not know right away, like how you, did I not save it? Jesus. So Visual Studio will do this stuff sometimes where if you change a file name and then you open it and it gets kind of wonky and won't save. So you have to like hit X and then, yeah, I want to save for it to actually save. It's weird. So, okay, so let's go here and then let's create empty. Let's call this code menu. Cool. And again, so this is following the same naming structure as we did here. So we have code main, code application manager, camera main, and then so you can start to see how all these scenes are starting to look similar, which is good because that's going to make working in them so much easier. So, okay, so then in our code menu, let's, did I not put the code on there? I thought I put the code on there. No, it's on the wrong thing. Okay, so so what we want to do is we want to effectively, let's start adding in the ability to switch between these pages. So let's go into code menu. And let's figure out, okay, how do we want to do this? Okay, so first of all, we don't want to do this anymore, which is good. We don't want to keep this alive past that. But what we're definitely going to want to do is we're going to need a way for our UI code to talk to this. So the easiest way, again, to do this is just to add a static instance for it. So we're going to do that. Let's go to menu, and let's go and then we're going to go instance equals this. Bam. Cool. So now any code that we have, like specific the UI code, can just boom access this, not without a problem. What are you mad about? Oh, that's why. Menu. Boom. There we go. Anywho, so what are the things that we're going to need to do? So we're going to need a way to kind of switch. Almost like switch screens or stuff like that. So let's think about it and let's say, okay, based on what the current UI state is, that's gonna be what screen we want to show. Okay, so it's pretty simple to do this. So we can go UI. Let's go pound region. Let's just create an enum. So we're gonna go public enum. We're going to call this UI states. And now we're just going to specify all the UI states that this screen has. So we have main menu, which is going to be the state that the app starts in. Or sorry, that this scene menu starts in. So we have main menu, and then we have select game, and then we have options. So what's nice about this is that at any time then, as long as we're maintaining the state, we can just query the menu and we can say, hey menu, what state are you currently in? Oh, we're in main menu. Oh, we're in select game. Oh, we're in options, which might be important for other pieces of code. I don't necessarily know of an example now of how that's going to be important, but I could see that being important. So, and then we can go, so let's do pound region member. Let's go properties. Let's see, remember okay, let's go private. And then this is where we're going to actually maintain what our UI state is. So we're going to say states underscore, let's see here, UI state. And that's going to equal, we want it to equal state, oh, no, UI states dot main menu. So again, we want main menu to be our state that we kind of initialize the scene to. So that's why we're setting main menu here. We may switch that going forward, and if so, we just need to update this variable, which is nice. And then kind of the same structure that we've had through all of our properties so far. Eventually, I'm sure we'll get away from that, but for now, we don't want. Oh, actually, we do. Okay, so hold on. At first, I was just going to make this have a getter, not a setter, because I'm thinking, okay, we don't want to change the state anywhere outside of this menu class. But that's not true. We actually do want to change the state. The UI screens themselves have the ability to say, hey, change state. So they're going to say, let's see here. So we got get, which is just going to return underscore UI state. Okay, not a problem. So this is where things get a little bit more tricky. So we can actually use this property to help us out here, which is what I personally like doing. So not only do we want to eventually, obviously, we want to update the state and set it, okay, but we may need to do some special logic every time we change state. So we're going to create, let's see here, let's go down here, let's create a helper method, end region. And then in this helper method, let's create one called, let's make this private. I'm going to call this change state. So what's cool about this is, what's cool about this is it's going to allow us to, every time we set the state from another class, so it's going to be really simple. The other class just goes menu.sinstance.UI_state equals, and then the new state. But what's cool about that is we're going to actually change the state down in this method down here. So it allows us to do kind of some more complex stuff versus just updating what the state is. So like it also allows us to maintain kind of order. So if things need to happen, like what we're going to do in this change state for sure is we're going to have to turn off a screen and turn on a screen. And obviously, we might want to do that in a certain order. Maybe we want an animated transition to happen when we're doing that. So all of that stuff can then be kicked off down here in this change state. So I'm actually going to rename this change. So I need UI states. Oops. But I'm actually going to change this to change UI state. Just again, trying to be more descriptive on my variable and class names. You can really run into a crappy situation if you don't do that. So so let's see here, change UI states. So in here we want to, so what do we want to do in here? So obviously we need to update current state to new state. So that's the last thing we want to do. So we're going to go UI state, maybe UI state equals new state. Okay, so that's the last thing we want to do. But we also need to turn off. So let's see here. So let's turn on new UI. Turn off old UI user screen. Okay, so effectively this is what we want to do. We want to turn on the new UI screen based on the new state that we're going in. We want to turn off the old UI screen, and then we want to update our current state to the new state. So now, here's the situation we get in though, is how do we know what state belongs to what game object? Like how do we know what thing turns on what? So that is where we're going to need some type of specification. So let's go ahead and create a subclass here. So bound region subclasses. And what we're going to create here is we're actually going to create an object. So we're going to go public class, and we're going to call this object UI state. So the main reason I'm doing it this way, by the way, I want to point out is I could do a dictionary. I could do a dictionary of UI state to game object. The problem is Unity doesn't allow you to serialize dictionaries natively in the inspector, so it causes like you can't, it just won't show up. So there's like weird issues around there. So instead, I'm just going to create a class which is pretty much going to kind of act like my own dictionary. But it effectively, you'll see what's going to happen. I'm going to create this class. I'm going to allow this class to be set in the inspector, okay? And then I'm going to kind of treat that class like a dictionary. If performance was an issue, I could on my awake in here, I could convert this this list of class type, or these list of objects here that I'm going to create. I could convert that to a dictionary if I wanted to, and then you do a dictionary lookup out of that. I might actually do that just for performance reasons, but we'll see. So let's call this UI state specification. UI state. Yeah, sure. Specification object. Okay. And again, this is just a system object. I mean, I don't have to do this. That's what it defaults to, but just to make it more clear. So we got a UI state specification object, and here we have public UI state. So we're going to go UI state equals UI states dot main menu, sure, doesn't matter. And then we have public. And then here we're going to get our game object reference to that, or linkage. And that's going to be UI object. Okay, so then we just need to create a public variable for this. Oops, didn't want to do that. Wanted to do that. Pound region variables. Pound and region. Okay, so we're going to create a public list of type, let's see here, UI state specification object. And then we're going to call this list our UI state specification objects. Very, very unique naming. But I guess that means, you know, you're naming the class well. So, anyways, so what this is going to allow us to do is in the editor, in the inspector, we're going to be able to, excuse me, set public references to the stuff that we care about. And say, okay, this state needs to have this game object turned on. So that's going to make things a lot easier for us. So kind of before I was mentioning that we might want to build this into a dictionary just to make lookups faster. So we'll go ahead and do that too. So we'll go private dictionary. And then we're going to do, let's see here. So what do we have? We have UI state and UI object. And those are UI states and game objects. So we got UI states to game object. And let's just call this UI state specification dictionary. Okay, boom, ballin'. All right, so what I'm going to do then is I'm going to, in my awake, so as soon as this thing is created, I'm going to, let's see here, fill my UI states lookup dictionary. So for people that don't know, if I was just using this list right here, I would either have to use like a link query or loop through all the elements of the list in order to find the UI state that matches the one that's passed in here. But by doing it through a dictionary, I can just say UI states specification like this, and then just do new state like this, and the lookup is much faster because the table is effectively already built. So so that's why I'm going to do it this way. So for int I, and so if you ever wondered why somebody would use a dictionary over a list, I mean that's lookups are much faster, so it's much more performant. So I is less than UI state specification objects dot count. And sorry if I'm moving a little fast at this point. I really just want to get the scene switching in before 11 when I have to sign off. So if I'm moving at a little bit of a faster pace than normal, that is why. If there's anything confusing or whatever, again, feel free to email me, write it in the chat. If I don't have time to answer it in the chat tonight, I will definitely send you an email in response if you email me. So, anyways, so let's see here. So what we want to do is we want to loop through all of our UI specification objects that we created or that we set in the inspector, which we'll do once this code compiles and stuff. And we want to grab that, and we have like UI state, for example. So what we want to do is we want to build a new dictionary off of this. So we have our dictionary dot add, and then so it wants a state, which is here, and then a game object. So we have the state, and then we just need to grab the game object that's in there. So ballin'. And then we also should, as just, granted it's happening in awake and we shouldn't have to worry about this, but it's a really quick call and, a one-liner. But we should make sure we clear our dictionary before we start filling it, just in case some weird thing happens. I don't know what could happen, but just in case, it's good. It's kind of a good self-check kind of thing to do. So anyways, so we built our dictionary. Great. So now our dictionary should exist with everything that we set in the inspector, which makes lookups a lot faster. So down here, what do we need to do? Okay, we need to turn on the new UI screen. Okay, so this right here, grab our dictionary, grab our element. This should give us the UI object then for this. So at that point, we can just call setActive. So remember, we're working with, at this point, this returns us of type GameObject. So we set active, and then we go true, because we want to set the new state to true. Cool. And then we want to turn off the old state. Okay. So effectively, we want to do the same thing, except this time we want to do it with what UI state was set to, and we want to set that to false. And then, obviously, our UI state then gets updated. So what's important here, too, is we want to make sure that we're only doing this if we need to. So we should check if state is changing. Now, there shouldn't really be a way for it not to, but just in case, it's good, again, to check this. So if let's see here, state underscore UI state does not equal new state. So this is just checking to make sure that our new state is different than our current state, because otherwise we're going to get a situation where we're turning off and on the same game object, and then that's just silly because it's going to end up being false. So so we just want to check to make sure it's different. So the good news is, at this point, at least this part of the code, the menu scene manager, is actually looking pretty good. I think that it should handle the changing of the UI state. Now, this is where you get into a weird situation where you're like, oh, okay, well, if this logic needs to exist, if each scene has its own scene manager that has this kind of UI changing logic, then that's crappy. You don't want that. You're just going to be duplicating code. Well, that's why most likely when we get to that point, if we get to that point, I'll end up making a base class called Scene Manager, which will share this kind of UI switching code or state switching code, and then we can port that to any of our scene managers. So like menu and main, they can both be a base type, inherit from base type scene manager. But main doesn't have any UI switching yet, and I'm not sure if game will have any UI switching. So for right now, we're not going to go ahead and architect that yet. But these are kind of the things that you want to start thinking about and get an idea of at this point. So anyways, so yeah, so we got menu. Pretty good state, I believe. So we're going to go back to Unity now. Hopefully all of this compiles. We did write a decent amount of code right there without checking if it compiled. But it did, so that's good. And then, so at this point, what you should be able to see is if I go to code menu. Oh, crap. So you notice how we don't see that public variable we declared. This is another good thing in Unity to bring up. So the public variable I declared right here, this public list. So the problem is this type UI state specification object isn't inherently serializable in Unity's eyes. So what we need to do is we need to go up to our class up here. And we need to go system.serializable. And what that's going to do is that attribute is going to tell Unity, hey, you can serialize this class. Don't worry. So anything public in here, it'll serialize. So now if we go back to Unity and it compiles, yay! So now our variable, our UI state specification objects, exists. So again, remember, this is where we're going to specify what state belongs to what UI object. So, so we need to create three because we have three states. So we have main menu, we have select game, and we have options. So at this point, we can just drag in, okay, main menu goes into that one, select game goes into that one, and options goes into that one. Great, pretty simple, right? So now at this point, we're just like, all the switching between, and we want to save, all the switching between these screens should work. The problem we have now is how do we tell our scene manager, so in this case our main or our menu scene manager, how do we tell this go ahead and do the state switching? So we need to add in some callbacks on these buttons to trigger those events. So let's go ahead and let's go to our UI main menu. So in our UI main menu, we're going to need region member variables. So we're going to have to create some public variables here for our buttons, so that way we can get reference to our button and subscribe to its onClick. So the Unity built-in button already has an event called onClick. So what's nice about that is you can just grab the button, subscribe to the onClick, and then get notified anytime that the button has been clicked. And at which point then you can do whatever logic that you want. So so we're going to create a public button, and again, I haven't imported the Unity UI, so that's why that's not working yet. But now that we imported that, it's all happy. So let's see here, public button, and what are our buttons? We have play game, so we're gonna have play game button. So here's actually another thing that I actually like to do that I haven't been doing much, and I might go back and refactor the rest of the code to do this as well, is that anything in Unity that you want to be set in the inspector, but you actually don't want other classes to get access to. So for example, this play game button, okay? I don't want any other class except for UI main menu to get access to this play mode button or play game button. But in order to get it to set in the inspector, I have to make it public. So then all of a sudden anybody that has access to UI main menu can get access to it, unless I make it private. But now it no longer shows in the inspector. Luckily, Unity has, there's a way to get around this. So so we're just going to go play game button, set this to null. So if we go and say, we set this to serializable field, add this attribute there, then even though that it's private, it'll still show up in Unity just like it's a public variable. See, so that's available. So that's something that's kind of a nice way to do to kind of help you maintain access rights to different variables, is by doing things like that. So we're going to go ahead and do that for our play game, our options, and our quit button. So let's go ahead and here, let's do some sweet copy pasta. So another thing too is now that I made that private, there we go. So all these need that, but we're going to call this our, so we have our play game button, we have our options button, and we have our quit button. Cool, yay. So now that we're going to eventually have references to these things, what we need is we need the ability to subscribe to their onClick. So we're going to go Unity methods and region. We're going to go private void start. Oh my gosh, how many times am I going to do that? Probably a lot. Anyways, and then we're going to grab play game button. And then when the onClick is fired, we need to subscribe to it, but we need to tell it a method on our end to call when when that happens. So let's go region, over methods, and region, and then we're gonna call these actually. Let's call this UI callback methods, and then we're gonna go private void. Ooh, that's not private. And then we're going to do play game button clicked. We're going to go on play game. Yeah, we're just going to call it on play game button. Cool. And all of the Unity onClick callbacks, they all just pass in void parameters. So so all of your callbacks will be like this. So we can say, so we need one for options button, so we can go on options button, and we can go on quit button. Boom. And then now here, now that we have those defined, we can just grab the reference to our play game button. We can go on click, and then we can go add listener, and that's on play game button. So it's a little bit different. On play game button. It's a little bit different than like built-in like C# events and stuff, because there's actually this add listener helper, but that's just because it's like a Unity event versus being like a straight up like C# event or whatever. So in case you were curious on why that's different. So somebody in the chat asked if I enjoy making games in Unity, and I definitely do. I think Unity is a great engine to make games in, especially mobile games. Prototyping is super fast. It's pretty friendly. There's a lot of resources online about Unity, which is great. You can definitely teach yourself if you If you feel like you want to start learning Unity, like there's a lot of resources, that's great. Kind of the biggest drawback of Unity, in my opinion, is that since it's so easy to get into, the Unity kind of developer market is very saturated with people that consider themselves like Unity experts. In my opinion, it's very easy to get started in Unity, but it's very, very hard to become like a Unity expert. Like, I've been working in Unity for 8 years now, and like I would say I'm barely in the kind of professional expert camp. Like, yeah, Unity is like super easy to get in and kind of get things going, but like to actually ship a title in Unity, like actually finish a game, especially one that continues to be maintained afterwards, yeah, it's quite difficult. So that's the problem with Unity, is like it's so easy to get into that you end up getting a lot of people that are like, oh, I know Unity, but they really don't. It just kind of it bugs me when it comes to things like hiring, like when we interview people like at work and stuff. So those are kind of the downfalls of Unity, but I like it. I mean, if I had to pick an engine, like for my personal projects, that's what I do. I wish it was better for making like something other than games, like straight up applications. Feels way too much like visual. So yeah, somebody was saying that. So the same guy was saying that it feels too much like Visual Basic to him. So I've never actually used Visual Basic, so I'm not quite sure what Visual Basic feels like, but possibly. For me, yeah, it's like it feels different than any, like I've used a lot of like in-house engines, like custom built C++ engines, game engines, and it feels completely different to like any of those things. So like I don't know, for me it feels quite different than those, but maybe there's other things outside of that. But anyways, back to what I was saying though, is like really the only thing that that I wish Unity did a better job was just like straight up like application development versus games. Like if I could build applications, like native style applications, as easy as I could, like through Xcode or through Android Studio or whatever, that'd be great. Like having better access to the native layer, like I work on a Bluetooth app, so like we have to do all the Bluetooth stuff at the native layer. It'd be nice if I could just do that at the Unity layer, but you know how it is. Anyways, so back to what I was saying, or back to what I'm doing here. So I created those public variables for those buttons. So our play game, our options, our quit. I assigned reference the actual instance of them in the hierarchy to my code. So what's going to happen then is when this code runs, which will happen as soon as I hit play, or well, as soon as this scene is loaded, we will subscribe to all these, and then these things will be called when we click them. So what do we want to happen when we click these? Well, if we remember, we set up those states earlier. So effectively what we want to do is we want to change states. So we have menu, and then we have our instance to menu, and then we have our state, our UI state variable. So when we hit play game, what do we want to do? Well, we want to change it to select game. Great. Same thing happens for options. When we hit options, we want to change it to options. And then on quit, we want to application.quit. So pretty simple logic going on at this stage of the app. It could get more complicated at some point, but usually menu navigation, when you architect it well, is as simple as just like a one-line thing when you hit a button. So at this point, if we confirm that our buttons are set in our main menu, okay, and we confirm that inside of our scene manager, our references are all set, which they look like they're all set. At this point, we should be able to just run, and it should switch between pages for us. Now, it's noted that I don't have a back button, so there's no way to go back. So I have to hit play and then switch the thing and all that fun stuff. So keep that in mind. But we should get an idea of the base logic here. Oh well, some way that button how'd that break? Well, it looks like our progress bar broke at some point. So let's go ahead and look at that real quick. So our fill did not look the way it should look. I think when I switched the canvas scaler, the fill got a little messed up. Wait, what am I stretching here? All right, I don't know what just happened. So our image fill. So I should be able. Trying to figure out what happened to our image fill. That was broken. That got broken. Yeah, I don't know. Weird. Oh, yeah, I guess now that I switched the size of the canvas through the canvas scaler, I had to adjust this as well. Okay, that should look better now. Okay, let's save that. All right, so hopefully the progress bar looks better. I think it will. Okay, cool. Progress bar looks good again. Yay. All right, so we're in our thing. So in theory now, again, everything is always in theory. When we hit play button, or sorry, play game, our main menu should turn off and our select game object should turn on, and we should see the select game text. That went to options. Interesting. So clearly something went wrong somewhere. Let's take a look at that. Let's see. Did I specify the wrong object here? So there's a couple things I could have done wrong here. So select game definitely looks like it's going to the select game object. Is my text wrong? Nope, my text is right. Okay, so fun debugging this will be. All right, let's go back to code. Maybe I messed up in code. Oh, yeah. So I was actually subscribing to, for each of these, the wrong, well, I was subscribing first to the correct play game button code, but then I was subscribing play game button to on options and play game button to on quit. So all three of the methods were being called, and since options was the second one to be called, that's why we were moving to the options. So so in theory, this should now be correct. Let's see your main menu. Line endings, my favorite. Okay, so now let's go back to main. So now that we've set up, by the way, now that we've set up our main scene to kind of do our initialization and stuff, we want to always start in the main scene then when we're running through the game. I might write a helper eventually to detect if you're in a different scene and load you into the main scene, but that's something that you should consider, is that once you kind of set up an initialization scene, you should always start there. Otherwise, you might get weird issues where like application manager doesn't exist because you never went to the main scene. But anyways, okay, play game. Yay, select game loads, and then let's go back to the main menu again, and then when we hit options, yay, options load. And yeah, you can see that all it's doing is it's simply turning on the options UI and the main menu UI and stuff. So anyways, I think this is a pretty good stopping point for today. Next week we will go ahead and start populating these UI menus, which will be cool. And then we can kind of start talking about more of the core mechanic. I think next week it would be great to finish off this main menu UI, at least in terms of the kind of the first pass for it, and then start working on how the core mechanic itself is going to work. Like, what is going to be the best design? And then we can start talking about some of the fun stuff, which is going to be the tools around creating the actual puzzles, because I don't want to just hand create the puzzles from level 1 to level 100. That would take forever and not be very fun. So instead, I want to write a tool that allows me to kind of live click on the cubes themselves. So kind of come in and say, okay, like tool is running, come in and just start clicking on these. And then after I start clicking on these, after so many things, say, okay, save, and boom, save that out to some specification that later then gets loaded into the game as like, okay, this is level 34. I'm going to define level 34. Click, 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 click. Okay, I'm defining level 35. Click, 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 click. But first, you got to get the core mechanic down before you get to that stage. But I don't know. So those are kind of tools around creating of the puzzles. I think will be really interesting for people, as well as kind of the data side of things. That's another question I get asked quite a bit, is how do I make a save game file in Unity and stuff like that. So we'll talk about how we'll save things like progress and where you're at and all that kind of stuff. So yeah, so if anybody has any questions, I got about 3 minutes. So if anybody has any questions, please do it in the chat right now. If not, feel free to email me at Andrew gmail.com. Like I said, I got like 38 emails last stream, so so it seems like people definitely enjoy emailing me more than talking in the chat, which is perfectly fine. If for some reason I did not respond to your email last time, I wasn't really expecting how many emails I got, so this time I'm definitely way more prepared. Set up some filters and some fun stuff. So if you want to send me an email, or if I didn't respond to your email last time, just send it. No problem. It usually takes me a couple days probably to get through them all, but like for sure it'd be answered by the next stream. So yeah, so cool. Yeah, so I'm not seeing any questions. Trying to give it a little bit of time for the stream to catch up, but yeah, so feel definitely go check out the archive on YouTube, as well as if you missed the first stream, please check it out on YouTube. It's great to, I think, understand where I'm coming from on some of the stuff that I'm saying. Like each stream is going to be building on top of each other. So yeah, so okay. So it looks like it's rolling at about 11 o'clock here. So I'm going to sign off. Again, I will post a link to the YouTube archive as soon as it's up on any of the Reddit posts that I made, as well as I think I can do it on like the channel feed in Twitch as well. So yeah, so everybody have a good one. Talk to you later.